Is this working? Is the mic working? Hello? Perfect. Yeah. Good morning, everyone, ladies and gentlemen. My name is Munif Al-Munif, and I'm here to talk to you about New Lab and the Mining Innovation Studio. So thank you all for coming. So just to start, New Lab is a global venture platform for critical technology startups. What does that mean? It basically means our mission is to actually accelerate the commercialization and let's say advancement of critical technologies within high impact industrial sectors. Specifically, if you look at mining, mobility, logistics, energy, built environment, and we cover all of these sectors. But today we're going to be talking about mining mainly. So essentially what we're trying to do is lower the barriers to entry for all of these startups. What does that mean? We try to provide them with the infrastructure needed in order to scale and grow. We try to provide them with the customers and access to capital as well. So in reducing the barriers to entry, what does that actually mean? We provide technical infrastructure, which is basically accessing to piloting sites and shops and labs to help reduce the development timelines for real-world testing and deployment. We provide access to the startups to have access to commercialization projects, where we partner with industry partners and government so that they can actually pilot their technologies and proof of concept of the technologies, after which we actually invest high-risk capital into those startups as well. Our model tries to align public and private resources to catalyze that startup ecosystem in strategic geographies. So specifically, if you look at from the left-hand side all the way to the right-hand side, specifically, we start with applied research to tech transfer and formation, lab to pilot, and then pilot to demonstration, and then finally commercialization. Across all of them, we try to provide several levers for the startups that can actually capitalize on, whether it's blended capital, starting from the bottom to the top, blended capital, access to incentives, policies and regulations, whether that's sandboxes and whatnot, offtake and commercialization agreements, providing the shared infrastructure that I was talking about earlier, and then finally establishing that manufacturing and supply chain for the companies. So our model has been proven. We have a global track record of helping the startups scale faster. So if we look at some of the numbers on the right-hand side, in 2023 and 2024 alone, 42% of our pilots have advanced towards commercialization. Our startups have actually raised 6.5 billion in 2023 alone. We raised almost $600 million just from January until August. These are the different models in terms of providing mergers and acquisitions, tech licensing, POs, investments by partner, whether it's joint ventures and whatnot. Since 2017, we've launched almost 110 pilots, and our companies have achieved around 32 exits. So you probably can't see it here. This is actually a map. Our outcomes basically, scale faster through a place-based model. In all of these geographies, whether it's Detroit, we started in Brooklyn, now we have in Detroit, and then currently in Riyadh, we also have in Uruguay. We try to translate everything we do into economic impact, whether that's job creation, establishment, and commercialization. These are some of the technology startups that we've actually invested in. Safe AI, actually, the first one on the left, they're here today. They're actually in our booth. They're at the beginning of where New Lab booth is. So again, talking about the place-based model, we try to provide access to infrastructure, and that includes labs, shops, machine shops, where the startups can actually work on prototypes, can actually build those prototypes. They can actually go ahead and work on them so that they can come up with that minimum viable product. We have offices, as I said, in Brooklyn and Detroit, Montevideo, and currently we're expanding to Riyadh as well. So in terms of the projects that we actually launched, we've partnered with 60 plus industry and government partners across different geographic locations. As I said earlier, we launched over 100 plus pilots where more than 30% have advanced towards commercialization. This is an example of a company called Mythos AI that does port mapping in different ports, and they were doing it in the Port of Michigan at the Port of Monroe. That piloting actually yielded in an $8 million sales pipeline. So in terms of infrastructure, the piloting sites that I was giving an example on the left-hand side, you can see the company Mythos AI doing that port mapping. We try to provide that piloting sites for all startups so that they can actually test all of these things. Partnering with government is also a crucial part in terms of providing that regulatory framework and zone. For instance, in Detroit, we were provided with a transportation innovation zone where we can do pilots across that entire zone on the right-hand side. So we believe New Lab Riyadh will create that magnet for global talent and high velocity startups that will create billions in new value in the region. We're planning to focus on several sectors, even though currently, we're at the Future Minerals Forum, we're focusing on mining, but we're definitely going to be looking at all of these sectors moving forward. We're planning our platform will definitely drive startup across these key industrial sectors. As you all know, as part of the energy transition, there's this unprecedented demand on critical minerals, and that demand is actually driving that imperative for innovation in the mining sector. And we believe that the kingdom has structural advantages that can be leveraged to meet such demand. These are some of the areas that we're going to be focusing on as part of the KSA Mining Innovation Studio. The first part is actually discover and prospect more, which is basically accelerate the exploration identification of mineral resources. Develop and mine better, which is basically increasing the efficiency and productivity of mineral recovery. Operating sustainably across the entire value chain in terms of reducing emissions and whatnot. And then finally, recover, process, and refine minerals. The entire, let's say, processing part of minerals. Stay tuned. There's going to be some announcements in the coming days on the specific part in terms of public-private partnerships that we've developed. Finally, we have these 25 plus startups that are being represented here at the Future Minerals Forum. They are where the New Lab booth is, where the red carpet is. Look for the red carpet and you'll definitely find us. So we'd be more than happy for you to come and see and meet those startups so you can actually see the different technologies that they're actually working on. Because I'm a bit short on time, I have to conclude. Thank you all for your attendance and kind attention. I'll be more than happy to answer any few questions you might have on what New Lab does. All right. Do we need? Oh, yes. Sorry.
Hello?
Maybe tell them to project the slides again, just in case. Yeah.
Do you guys take projects on a global level or certain industries, regions?
So currently we've started in Brooklyn, New York, and we've expanded into Detroit, Uruguay, and depending on different geographies and the needs on those geographies, we're currently expanding into the kingdom, and that's why we're expanding here. There's definitely other markets that we're looking at, but our model relies on having a place-based model, which is basically building that infrastructure that you see, having the shops and labs, creating that
The whole physical
ecosystem,
place,
the,
yes.
the, en-
Yeah.
the entire infrastructure of having the shops and labs where the startups can actually be housed. They can all work on prototyping. They can all work on piloting and helping those startups accelerate and commercialize.
When are you starting in Saudi? Any operation?
We've already been here for the past, 6 or 8 months. We're hoping to launch our beta space in this upcoming year in 2025.
You started taking projects in Saudi?
We're already in partnership with and in talks and conversations with a lot of industrial partners. Yes, we do have a lot of upcoming projects coming up.
Thank you.
No problem. Can I go back in this or? Oh yes, perfect. Yeah, I'll leave this to. So going back to the point, having that place-based model, a unique one, will actually help drive that, let's say, traffic for startups. These are our offices in Detroit on the left-hand side. And even though they look like offices, but then within those offices, you'll see a lot of the shops and the labs that are on the right-hand side.
Yeah, hi. This is Sultan from KAICC. Yeah, I would like to ask you about the startup companies. Do you have companies here, startup in Saudi Arabia, or still working?
For some reason, I can't hear your question.
Yeah, I have a question about startup companies. Do you have startup companies here in Saudi Arabia, or still like in the process of initiate that kind of startup companies?
So, New Lab is a venture platform. We try to bring in startups from all over the world, whether in KSA or globally. Currently, we've seen a lot of interest from startups that are coming in from all over the world to come to the kingdom and operate here. But we're definitely asking all kinds of startups, locally and regionally, within the GCC and the broader MENA region, to actually come in and start working here in the kingdom. Yeah, no problem. Any additional questions? My email's here. Feel free to email me. Where is it? Feel free to email me if you have any questions. If you would like to know more about New Lab, we can tell you a little bit more about the projects that we're actually working on with the different industrial partners, and what we're trying to do in the kingdom in the coming months, inshallah. Thank you.
Oh, sorry. Oh, okay. Good morning, everyone. My name is Fergal Murphy from IGS. I'm going to talk to you about the Saudi Geological Survey Regional Geoscience project, and in particular the Airborne Geophysics. First of all, I'd like to acknowledge our partners, the Saudi Geological Survey, who are carrying out the work. IGS leads the technical partner consortium, and I acknowledge our other partners in that, and also want to acknowledge the airborne geophysical contractors who are acquiring the data, Excalibur and Standard Geophysics. Overview of my talk. I'm going to start with a little bit of background and the context in which this new project started. Talk briefly about the survey methods and the design, and I'm going to show some data examples and show how the data might be used. This is a bit of an overview. I'll go through it briefly. It just sets, it's a summary of the typical exploration process. On the left is where the role of governments come in delivering pre-competitive geoscience data. And on the right is the role of the larger mining companies at pre-feasibility, feasibility stage. SGS is carrying out this project in the context of supplying new pre-competitive data and hence stimulating exploration in Saudi Arabia. So the regional geological survey program has three main components. There's airborne geophysics, geological mapping, and geochemical sampling. My colleague Jordan Gayoso from GTK is going to talk about the geochemistry later. I'm going to focus on the one on the left, the geophysics. Within the overall National Geoscience Initiative, which is part of Saudi Vision 2030, SGS is running this National Geoscience Initiative, and the RGP, Regional Geoscience Program, falls within this. And I spoke about the three components. There's also a National Geoscience Database, which all the data products from the three main data acquisition programs will feed through to. So getting to the geophysics, it's a very large project. It started back in Q4 of 2021. It's still in phase one, which is acquiring magnetic radiometry and radiometrics over the whole of the Arabian Shield. The map on the right shows the coverage to date. So it's about 80–85% complete. Block 1 in the northeast in blue has been completed by Standard Geophysics. They're currently flying a small extension, which is the bit sticking out on the east. Block 3 in the south and Block 2 in the northwest are being acquired by Excalibur. Block 3 is almost complete, and Block 2 is about 65% complete. The areas in red are exclusion zones, restricted zones for various reasons. They will not be covered. The whole project, phase one, is 2.25 million line kilometers. Its scheduled acquisition and final products are scheduled to be complete by the middle of this year, and it's, to my knowledge, the largest single survey in the world. To date, over 2 million line kilometers have been acquired, 2 contractors, up to 9 aircraft deployed, and almost 12,000 hours of flying, and there's been almost 2,500 production flights. This sets the project in an international context. On the right is a map showing Saudi Arabia, and in particular the Arabian Shield in orange, on the same scale as Australia. Large countries with a strong mining history like Canada and Australia started acquiring airborne geophysical coverage back in the 1950s. Canada, for example, has not yet completed the whole country at 400-meter line spacing. Some recent examples, the Gola Craton in Australia has just finished back in 2019. That was 4 contractors, took 2.5 years, 1.7 million line kilometers. So you can see that it's a major achievement for Saudi Arabia to acquire a project of this size in just over 3 years. There's been some challenges. The weather in Saudi is very difficult for flying, lots of wind, dust, poor visibility, and also very rugged terrain over especially the western part of the Shield. But nevertheless, over 2 million kilometers have been acquired to date safely and to excellent technical specifications. Going back to old data over the Shield, there was legacy airborne geophysics acquired starting in the early 1960s and complete by the early 1980s. This was acquired using the technology of the time. The line spacing was from 500 meters to 2 kilometers. The altitude was 150 to 300 meters, probably higher over areas of rugged terrain. The technology has advanced since this data was acquired, and it's no longer fit for purpose. So this is some of the reasons why we're acquiring new data. There was large technological improvements in airborne magnetics and radiometrics from the 1960s up to the 1990s. Been minor incremental changes since then, but most of these changes date back to the 1980s and 90s. Primarily use of differential GPS for navigation and positioning, greater accuracy, recording rate and sensitivity of the magnetometry instruments, digital compensation for the magnetic effects of the aircraft, measuring horizontal gradients, such as this is an old image, but you can see the sensors on the wingtips and the tail. This helps to apply enhanced gridding and interpolation between lines. Digital data processing, greater emphasis on safety, and of course the final products are now all digital. So why magnetics and radiometrics? These are the standard methods for baseline geophysical surveying. They're relatively low cost per line kilometer compared to other methods. Relatively rapid to acquire. The systems can fly even through the Saudi Arabia summer. They're good for both structural mapping, particularly magnetics, and radiometrics and magnetics in the case of lithological mapping. They can be flown on the same aircraft. And they meet the key objectives of this project, which is to acquire a set of baseline geophysical data to support the geological mapping project, and importantly to stimulate exploration activity, and of course to foster geoscience research and skills development in the kingdom. So all these advances in technology that we looked at enable much higher resolution magnetic and radiometric data to be acquired nowadays compared to the legacy data. So it's in this context that the project started. Just very briefly talking about the methods, the image on the top left is just a reminder about magnetics. The Earth's field is a dipole, so the magnetic anomaly that's measured depends on where one is on Earth, and typically one applies a transformation from the recorded data to a grid and then to what's called a reduced to the pole magnetic map, which makes it easier to interpret and focuses the anomalies over their causative source. The images on the bottom and the right refer to radiometrics. Radiometrics is only sensitive to the surface. The depth of penetration is only a few decimeters. And the assumption is that the gamma radiation emitted from the surface represents that the surface sediments represent the bedrock lithology. Of course, that's not always true, where we get transported eroded sediments. But typically over, especially the plutonic structures in the seal, we get very nice radiometric signatures that reflect the bedrock. A bit about survey design. So we choose a line spacing of 300 meters for the project. With the tie lines, so that the main survey lines are running in the northern two blocks, running northeast, southwest. And in the south, running east-west. This is so the lines are running roughly orthogonal to the geological trends. As I mentioned, the systems are measuring gradient, which allow enhanced imaging and enhanced gridding, and gives better resolution data, especially offline. The data is suitable for interpretation at 1 to 100,000 scale, but it can actually be pushed down to about 1 to 20,000 scale. The survey height is 60 meters nominal, but of course where there's rugged topography, the pilots have to fly much higher than this. And some areas along the western escarpment, the radiometric data is missing because the plane was too far above the ground, and there are some gaps which were always expected. The airports are shown in red. As you can see, there's a limited distribution of airports, so sometimes the survey acquisition becomes quite tricky, and the pilots having to fly a long ways to get data. The line spacing is obviously a trade-off between cost and requirements, so the 300-meter spacing with radiometry measurement allows essentially one to replicate more or less what would be acquired with 200-meter line spacing and a single sensor. A bit about quality assurance, quality control. IGS and through the technical partner, we're hired by SGS to carry out independent quality control on the project. Just a reminder, a difference between quality assurance, which is essentially the written specifications. It's everything that goes into the contract. and subsequent memos to provide the clarifications. This is the reference benchmark on which the data will be evaluated, and the quality control is the assessment of all the data produced by the contractors against these tolerances. And all of the data produced on the project has gone through quality control by the technical partner. The data products include grids, geotiff images, line database maps, and GIS packages. So far, some of the magnetic data grids have been loaded up to the National Geoscience portal. One can download these. The image on the bottom left is a screen capture of how the NGD portal looks. And you can get data for quite a few areas already. The image on the right shows what you will find on the portal by the end of this week. There will be a new data launch this week. Some of the data in gray and light blue in the bottom is still not absolutely final, but it's quite usable for interpretation purposes. The current geophysical data from the project is just the reduced to the pole rasters. One may request other data products from SGS via their portal. Just a quick note about if you decide to download the data, you should be careful to apply a suitable color scheme, a color stretch, and there's lots of different ways to look at the data, and not all software shows you the most suitable color schemes. I put as an example, a rather egregious example in the top right, typical rainbow color scheme, which is not what you want to use. On the bottom right is a perceptual color scheme, which this particular one is designed to show the large anomalies, both positive and negative. And the one on the right is a derivative, which is it's good to show in grayscale, so you can see the detailed structure. So I'm now going to show some data examples. We're going to first of all look at the legacy data and compare the new data, see the uplift. In a lot of these examples, you will see structures such as intrusions, faults, dike swarms, folds. I'd like you to focus on the transition between slides. So this is the reduced to the pole legacy data. Subtle feature in the back is the first vertical derivative of that in grayscale. This is the first vertical derivative of the legacy data alone. This is obviously a big intrusion and a smaller intrusion to the left. And as we go to the new data, you can see the uplift compared to the old data. We start to pull out a lot more details. There's some nice structures coming through. You can see sinistral faults cutting the intrusion. You can see lots of detail in the contact aureole, zonation within the intrusions. Obviously, there's lots of dike swarms. There's one cutting east, northeast, south, west, southwest here. There's another one northwest, southeast. There's a nice fold structure down here, and a subtle one here as well. And you can clearly see relative timing of structures from the offsets. And over on the far right, you can see how there's some sedimentary units being picked out, and there's some pinch outs. And this is again just the RTP to see the amplitude of the magnetic data. So this helps us to identify which are the biggest anomalies, whereas the previous one kind of shows us the structure. This is the Sentinel-2 imagery false color composite for the same area. And then this is the radiometric data, a ternary image from the radiometric data that was acquired on the same project. So when we see how these different data sets complement each other, you can see the white on this is where all of uranium, thorium, and potassium have high counts, and the black, like this image up here, is where all three have low counts. So typically the felsic intrusions will have high counts, but the radiometrics is quite useful for teasing out lithological variations, especially within the intrusive complexes. And this is the Peter Johnson 1 to 1 million geology map, and the structures on that are the 1 to 500K. So you can clearly see the benefit that will be added by this new data set, especially in mapping what's beneath the superficial cover, which was in blue in that last slide. And I'm now just showing some preliminary interpreted structures that have been generated by the contractor. Just added some faults. Interpretation is very much a function of the time spent doing it, and obviously there's some more structures that could be picked out. But you have some faults, mostly sinistral, and some dike swarms in red. And then there's some context in black, and it's a bit hard to see, but there's some lineaments and trends in blue. And this is a lithological interpretation generated by the contractor. As I said, interpretation is a function of the time spent. There's more detail can be pulled out with more time. And next we'll move on to area 2. Again, I want you to focus on the transitions from slide to slide. This is the legacy data. Again, we're looking at the RTP in color on top of the 1VD in grayscale. And the arrows in red show some of the mineral occurrence data. These are gold occurrences. These are all available publicly on the National Geoscience portal. We can see how the occurrences line up along the faults. And then moving to the new data, it's obviously showing a lot more detail again, and we can clearly understand how the what the relationship is between these mineral occurrences and the location of context and faults. And again, this is the geology map from Peter Johnson. And this is the 1 to 250K geology map, which was also compiled back in the, I think in the USGS BRGM days, and around the time that maybe it's been updated since. But this was mostly focused on the superficial cover. We can clearly see all the Neogean Quaternary cover in the middle in yellow. And then we see how the magnetic data is really illuminating the buried structure and giving us new information. And a few slides, I'm going to show the area in red in a bit more detail. Again, I just want to note the difference. This is the contractor interpretation of the lithology and structures. Again, it's always going to be a work in progress. And this is the radiometric data for the same area. The large area in red are transported sediments, red indicating they're very high in potassium. This probably reflects their origin from some of the more felsic units. And the whole area on the left is relatively low counts, a lot of black, reflecting more mafic composition. And we can see how there's some like intrusions that have very high counts in white, and there's also some structures like this one here that look like an intrusion with very low counts. So we can see how the radiometric data is really helping to map the lithology. And again, this is the Sentinel data, and again, you know, sometimes it correlates with the radiometric, sometimes it tells us different information, so it's always good to look at all these data sets together and integrate them in carrying out any interpretation. So next, let's zoom into that red box. So I'm showing you this at what would be a 1 to 100,000 scale. And again, the same mineral occurrence data. We're looking here at what we call the first vertical derivative. So I typically use this product a lot for looking at the structure. But one can look at other higher order derivatives, which show a little bit more detail. So if you're mapping structures in a lot of detail, you want to use all the different derivatives. Again, this is the second vertical derivative, so it's the derivative of the first derivative. And we see how there's more detail being pulled out. And again, I'm just overlaying the contractor-generated interpretation, but there's obviously a lot more detail that one can pull out of this. And this example here is what's called the tilt. And this is a very useful contact mapper. The areas in white reflect the location of contrast, i.e. magnetic differences in magnetic susceptibility across faults and lithological contexts, etc. So this is quite a useful product for locating edges. So in conclusion, so a new magnetic and radiometric data set has been acquired in just over 3 years. Acquisition is ongoing, but the acquisition will finish in the next few months. All data has been independently QC'd by the technical partner on behalf of SGS and meets rigorous modern day standards. Initial data release on the NGD portal was the FMF last year. There was a subsequent release in October this year, and there will be more data released this week. The magnetic data is available for free. Currently it's available as reduced to the pole 1 to 100,000 map sheet tiles. The user may download these, stitch them together, and may calculate derivatives and enhancements using free and commercial software. Other data, grid database products, including radiometrics, may be requested from SGS via a form on the portal. The data is currently being used for the geological mapping of the Arabian Shield project, which is being done at 1 to 50,000 and compiled at 1 to 100,000. SGS very much encourages use of the data by private industry, universities, and researchers. There's obviously lots of potential for commercial and research uses over years and decades to come. Phase 2 and 3 of the geophysics project will commence in 2025, later this year, and will run for the next 3 years. And this will target the mineral belts and other target areas picked on the back of the phase 1 work. This will involve additional methods, including time domain, electromagnetics, gravity gradiometry, magnetotellurics, and probably also more higher resolution magnetic data in the target areas. For further information, you may contact Dr. Wadi Kashgari, who's sitting down here in front of me, who leads the RGB project. Also, Engineer Mustafa Maki, who leads the NGD project, and Dr. Hussein Harbi, who is the RGB geophysics lead. And my contact on behalf of technical partner is there, and also the project manager of the technical partner, Dr. Esko Korkiakowski. And I'd like to thank you all for your attention and acknowledge our partners and SGS, and happy to take any questions. I believe we have lots of time, so I do have some more data to show if I'm allowed, but if I'll first take questions.
Thank you so much. I'm Ziad Al-Bashir from the Center for Industrial Revolution and KAICC. It's obvious to us when you use the magnetic and you're imaging very well the structure, and even using the calculation of the derivative to see all elements that guide us to see the mineral depositions. But in terms the big picture that we need to see or increase the level of the confidence to see the minerals, what exists over there. Are you going to use in future, or like pilot studying exists at each block to show the type of minerals that exist over there? This is one thing. The second, how about another technology? If we talk about hyperspectra, for example, or EM to look at as using as a satellite technology, that may be fast and easiest way to empower the technology to increase the level of the confidence, because I think the final goal, how to show the big picture of the mineral reserves that exist in the Arabian Shield.
Yeah, for sure. Obviously, this project is just one piece in a larger jigsaw, and our main job is to ensure that this data set is fit for purpose. We're not the end users of the data set, so our core responsibility is to acquire this data on behalf of SGS and ensure that it's fit for purpose, so that other people can use it. And I know that SGS has plans to develop a data analytics center, and all these various data sets will be used in the future. And I didn't mention, but of course one can apply to this data and all sorts of edge detection and machine learning techniques, and one can integrate all the different data sets. You mentioned hyperspectral, for example. Satellite hyperspectral is being used as part of the geological mapping program, so, and along with this geophysics. So the mapping people are using hyperspectral, the geophysics, and the existing geological mapping data, the legacy data, to prepare preliminary field maps before they go out into the field to do the detailed mapping. And of course, this data can be used for target picking, but if there's phase 2 and 3, which will require new data at higher resolution and different types of geophysical data. I mentioned EM and magnetotellurics and gravity gradiometry. But of course, if a private company wants to do exploration in a particular area, they may decide to do their own survey work at a tighter line spacing on the back of this data set. For example, gold exploration people may want to do survey at 50-meter line spacing. Those faults I showed, obviously this data is really good, it's a big improvement, but it's probably not quite sufficient in itself if you're looking for structural gold. And obviously there's the geochemistry data as well. My colleague Jordan is going to speak later about that. There's 90,000 geochemical samples which have been taken over the whole of the Arabian Shield, so that provides a baseline data set for acquiring new geochemistry data. So it's very much about the integration of all the data sets. Do I have some more time? I'll just flick through a few extra slides just to show again the quality of the data. This is a whole intrusion complex showing here the RTP in a different color scheme, so you can see the amplitudes involved. Over on the far right, there's a deep negative, which is an UFI light, a strong remnant magnetization there. This is the radiometric data, the ternary for the same area. Obviously some very high counts over the south. Some of the intrusions, some more of the intrusions of different characters. So the geology, again, this is a different area, a major sinistral system cutting through it, but lots of mafic units in this north-south running sinistrally displaced a shear, a fault zone. Again, this is the ternary for that area. And this is the geological map for that area. And yeah, that's just some nice pictures to show the diversity of the data. So yeah, thank you very much. Oops. I'm sorry. Sorry, I did what you didn't ask me.
Donc là, je clique. Oui, pardon? Ça, c'est pas ma présentation. Oui, oui, c'est le titre, c'est le titre. Et donc quand je... Okay, great, excellent. Good morning, ladies and gentlemen. It's my pleasure to be here today. I am Sophie Zurkia, and I'm the CEO of a company called Veran. To make it confusing, we changed our name last year to Veran. We used to be CGG, Compagnie Générale de Geophysics, and so we're a geoscience company, and we've been actuating in the oil and gas sector for more than 90 years, actually 94 years to be exact. So we've got a great deal of expertise in geoscience, and I'm here today to show you about how we can translate or we can reuse that expertise from the oil and gas and applying to the mining sector. Okay, so I've mentioned that Veran is an advanced technology company. We're in digital, and we actuate in the field of natural resources, so oil and gas primarily. So 90% of our business is in these three core businesses. And so geoscience is where we do the imaging. So we take large amounts of geophysical data, seismic data, and we make very precise images of the subsurface in very complex environment, being on land or offshore, deep water, for example. The second business line is earth data. You're not going to be familiar with that business in the mining sector. It is where we invest our dollars and acquire data on our behalf, essentially geophysical data, but also it could be geological data, it could be public data, geochemistry data, well data. We put it together to create packages and information that helps the clients speed up their discovery cycle. And this is a business model, I have an example of that later on, that we're trying to apply to the mining sector. So we do have a complete data set for the mining sector in the US, and we've been experimenting with that business model. And the sensing and monitoring is where you have all the sensors, onshore, offshore, that are used to create those images to acquire the seismic data. So this is our core businesses, and of course, recognizing the energy transition and the fact that oil and gas might not be a growth value proposition for the long-term future, although it's very healthy and doing well right now. We wanted to find new revenues, new avenues of growth for the company for the future, and we looked at our capability and how we could apply those capabilities to other sectors. So we selected three areas where we're applying our expertise in technology. First one is low carbon. And in low carbon, you've got carbon sequestration, which is very straightforward from oil and gas. This is you're storing carbon deep down in the reservoirs. It could be aquifer or old oil and gas reservoirs. There's the minerals and mining, and that's going to be the topic of today. And so we've started these initiatives back in 21. So we're 3 years into all of those, and so we really are ramping up our expertise and understanding of what we can do in those various sectors. I have to say that last year in 2024, we started to see some very significant growth in those two sectors. So we started from a very low point in minerals and mining, but we more than doubled our revenue in that sector. Carbon was even more than that. The second area that we're looking at is digital. And in digital, we have two areas, is data transformation, data curation, data ingestion. Most companies that are dealing with subsurface data and different types of subsurface data are having a big data problem. So they don't know what data they have. It could be buried in documents. It's not always digital. It doesn't speak to each other. So everybody wants to do that AI thing. But in order to do AI, you have to have a good solid foundation of data, and data that is talking to each other, that is correlated with each other. Otherwise, you're not going to be able to get those insights. So we started that journey inside the company back in 2015, because we had loads of different types of data, geological data, geophysical data, and we wanted to start automating and being a lot more efficient at what we were doing. So when we realized that we developed tools, AI tools and systems and dashboards that were really helpful, we started to offer this to the market. So we're primarily, again, targeting our oil and gas clients, but I know there are discussions today with mining clients. So this is about making sense of your data, knowing what data you have, classifying, curating, classifying your data so that you can extract insights from it. The last one is infrastructure monitoring. It's a natural extension from the sensor side, is repackaging sensors in order to provide solutions for health, structural health monitoring of, say, dams, bridges, been involved in mine tailings, into the structural health of mine tailings, so you can record vibration, or you can do the imaging side. And actually, it's interestingly, I saw the Saudi Railways was in this forum. We're working for Saudi Railways to identify cavities that are forming underneath the railways. So this is the imaging part, but the other part is the vibration and looking at natural vibration of infrastructures and inferring whether those infrastructures are getting older or having some kinds of problem and some intervention is needed. Okay, so I did mention all the way, I should have talked about the HPC. The HPC, high performance computing, is an enabler in geoscience. It is more and more critical, and I think the whole, definitely oil and gas industry and more industries are trying to equip themselves with high performance computing, because with the amount of data exploding, AI exploding, you need that computing to get to what you need very quickly. It could be physics-based type of computing, which is a lot what we do. So people think we solve everything by AI. I like AI, it's a nice tool, but it's when you have physics is still the best tool to get you the right answer, but AI can come as a complement. But HPC is fundamental to get you these outcomes. So those are the capabilities that I would call it we developed, but then our industry, sort of the geoscience industry, had to develop to respond to the oil and gas problem that are directly applicable to these other sectors. That's the data. We have all kinds of data that we own, or technically that we have the right to market. So a lot of experience with data. Now, going into mining, and the objective of my talk today is to show you examples on how we've applied, or our journey into applying our technology and expertise into minerals and mining. So what is the problem? Of course, we work in a macro environment, so there are geopolitical drivers and issue. If you look at the industry itself is faced with the ore quality declining. Very similar story, I always refer to the oil and gas, but for the old-timers in the oil and gas, some of them are here, same story, that the easy oil was over decades ago, and more technology was required to be able to get to the next step. And similar story in minerals and mining, so ore quality is degrading, so better characterizations needs to happen. Exploration success is declining and cycle time is increasing, which seems to be counterintuitive, that now with all the efficiency tools that companies have, that actually when you look at the numbers, the cycle time is increasing. Okay, said differently, geoscience and new technology is required to address these challenges. I should have mentioned here on that slide, there are different ways that the industry is responding to those challenges, including recycling, etc., buying companies. But really what we're talking about here is that bottom one, new technology and business models. So mining, as a result of the easy minerals having been found, it's getting more and more complex to find the new deposits, and therefore mining is getting deeper, more complex. And what we're seeing now is the limit of the old techniques, which is really drilling-based, core-based, and geochemistry-based. So I'm certainly not saying that drilling is not going to be there. Drilling needs to be there as a complement, but the more breadth of data you have, the better your answer will be, or your better your understanding of the subsurface will be. So here that picture is just an example of the kind of drilling that happens to characterize or to explore and characterize reservoir, and you have numbers of exploration and discovery, which is sort of going down. And these are the challenges. Exploration success declining, characterization is more difficult, and combined with that, all the industries are under scrutiny for the ESG performance. So you want to make sure you do things right, that you understand the rocks and the structure as you're digging, that you want to understand the hazards, you want to do things more optimally and reduce your footprint. So all of which geoscience can support. I'll skip that one. So if you look at, I wanted to give you some example and a feel for the kinds of solutions that do exist at various stages of the value chain. Again, it's not, people might think about geoscience and earth data as just an exploration tool. It is a lot more than that. There's a lot to do, of course, logically in that next phase of appraisal to characterize the rocks. Now we can get the rock physics from the seismic data. Probably in the past that people have dealt with seismic thought this is essentially a structural, something to make an image and understand the layers and understand the faults, understand the structure, but it's a lot more than that. Now you can get the rock physics and the reservoir parameters from the seismic. Of course, you need some calibration points, and that's where the wells are going to be important. But it's also used in all the way into the mining itself, and we had some projects with BHP that I will talk about, in which we've helped them identify new ore or bypassed ore that existed in their field that they hadn't seen previously, and so we were able to help them with that. So now going example by example, so this is first in the early stages, and this is where multiphysics is really important. So not so much necessarily the seismic side, but it starts with the gravity, the magnetics, and the electromagnetics, and the gradiometry. So bringing all these kinds of data together, possibly with some drilling data, some core data, chemistry data together to try and make sense of that subsurface and identify whether the area is of interest. So what's important in that stage is that you do this at scale, so that you could do this efficiency at scale, and then the data talks to each other, always correlated to each other. In other words, data leveling is extremely important in that stage. So this is just an example of what can be done. So you can use, I mentioned a lot of data, I forgot to talk about remote sensing, so there's a lot of information can be derived from those satellite images together maybe with this airborne type of data. And you bring it together, you could do spectral geology and start to get a view or first view of the surface layers and do quite a lot of interpretation from that. We have an example where mineral mapping was done over the entire Arabian Shield with that kind of technology. The other example I mentioned earlier was our Earth data example. This is our data library. So we invested our dollars in North America to create what we would consider a best-in-class geoscience data sets, so that the mining company could go running and really shorten that cycle. Because if every company does it, so this works really well and is a very well-established model in the oil and gas industry. But in the mining sector, it was sort of new, and we said, why not try it and see how it works? US is very conducive because there's a lot of different players, so it's a multi-client model, so we invest and we sell the same data sets to different clients. And that's what we did. So we did it in large scale. We had the GravMag, gradiometry, Airborne. We combined it with well data. We combined it with all data that was available together, and then made it in a consistent manner. So if you see something on one of the data sets, we could start looking at what it looks like in the other data sets and see whether that makes sense. So you get these levels of confirmation from the various data sets that are correlated with each other. Now, going into that sort of appraisal, planning and development, that discovery to mine operation can be over 15 years. In the oil and gas, in our core sector, in the oil and gas industry, typically you'd have 20 plus years, 20 to 30 years between discovery and first oil. Now, this has been the name of the game in the oil and gas industry. How do you get it shorter? And now some of the clients, ExxonMobil in Guyana, for example, got it down to 7 years. So that 15 to 20 years that used to be now is gone down to 5. How do they do that? They do that by investing earlier in better data. So ExxonMobil has acquired, 3D, extensive 3D seismic data from day one, where clients used to deal with 2D seismic data initially, and then it would take time to do the 3D. So everything takes time, right? So if you're trying to compress the cycle time, you need the best data from the beginning. Of course, you have to be cognizant that the budgets are the same. So probably the mining industry, the exploration budgets in the mining industry, I would call them, in the oil and gas industry, it's billions, it's 50 billions. Probably in the mining industry, you divide by, 3 or 4, that number, but still is not an insignificant number. And there are ways to acquire better data. So anything that you would do now would be better than what was done in the past. Because we've put our hands on some of the seismic data that had been acquired in the past. We would consider this sort of substandard in a way, and there would be a way for not a lot more expensive to acquire better data. It doesn't have to be the full-blown complex 3D and super expensive, but still better than what is being acquired today. And that's where those images of the subsurface are going to be very useful to define the ore body, to shorten that cycle, have that best data really early on, to optimize as well that planning and development. Because if you understand what you're dealing with, you could have a better suited, fit-for-purpose development plan and make sure you optimize your dollars from the beginning. Okay, so here's an oil and gas example, but we gave you that example to show you what good technology is, or best-in-class technologies is in the oil and gas sector. So this is an example in Oman with hard rocks, and show you in a space of 3 years how technology has been advancing. So this is like what was considered a pretty good image back in 2020, and you look at it 3 years later, applying elastic full waveform imaging, which is really a more complete and a more fidelity into the physical model that we're using to derive the subsurface image. I mean, you could have a much better view of the structure, and even complex structure with high dips. Typically in the past, the seismic wasn't necessarily, surface seismic wasn't great at identify highly dipping structures, but with this kind of elastic full waveform imaging and the fidelity, you're starting to be able to do that. And so that was an example for oil and gas. And this one is I think it's definitely a mining example with sort of I would call it a low-end sort of seismic data set, but still applying best-in-class algorithmics and best-in-class processing, even to data that is sort of, not as rich as what we deal with in the oil and gas. You still get a much better understanding of subsurface. You understand where the ore body is. You see the basement. And then you also identify those shallower hazards, which is really important as are you going to make your development plans and you're going to start doing the drilling. So I guess that's the line that you see in here. This is what seismic was acquired, and you see the lines here. Now going into more into that planning, development, and operations monitoring, this is really important to extract the rock physics. I alluded to it earlier, so it's not just about structure, but understanding the rock physics. Now, arguably, I've heard some mining players say, it's very difficult to get rock physics for the mining sector. I suspect that as we look at the problem more and more and deeper, we could start identifying at least some signatures, right? I mean, we're not going to be complete 100% right, unless you have validation from a well. But if you have some well data calibration, if you now start understanding the signature of certain mining or certain ores, then I think you could start getting into understanding the deposits and understanding the ore structure. So that's just an example of a workflow where you start using all the geoscience and the geophysics that you have, multiphysics, seismic, and putting it together and start deriving the elastic properties that are relevant for the mining. And so that's where you start looking at the porosity, permeability, the Young's modulus, and of course, the more calibration you have and the more understanding of that region you have, the better your result will be. But a lot of it can be data-driven if you have a good data set. So this is this is a testimony from BHP. They've actually presented this as a paper and they really, what they claim is what's underlined is better ore body knowledge facilitates more efficient mining and processing. So useful for, again, to think about the development and actually going into the mining itself. Now, what is it, there's always that price and cost and that sensitivity in the sector. Of course, it's not a perfect model, but there's a lot of drilling, and drilling is actually kind of expensive. If some of the drilling could be saved by having a better image, then you could save maybe 20% of the drilling, and that 20% you could reinvest in having this early upfront data. Then at the end of the day, you could still be better off and not make mistakes. And as you know, in any project, when you find something wrong later, it's more costly than when you find it early on, right? So the earlier you find about things, the better off you are, and so it avoids you to backtrack and change your development plans, and which is always, costly when it's late in the game. But of course, as a geoscience company, we like to see those nice images of the subsurface, and they're definitely quite impressive. And now going into that last operations side, you have to worry about the safety, and so I was talking about the hazards and the HSC side of things, but also you have to worry about the efficiency, and efficiency is about extracting the most ore you can with your OPEX, right? So you're spending money every day, can I get the most out of it? And so there are different solutions coming from the sector that are addressing those phases. And some of it, I'm not sure which one I have. Some of it is just the imaging, understanding the cavities, understanding the hazards. So this is more traditional geoscience or geophysics-based type of solutions. But there's others, as while you're drilling, imaging that, making images of that rock and identifying the ore. What we hear often is that as we're exploiting those mines, sometimes the ore disappears, and so you're trying to find where it is, and sometimes wasting dollars into trying to drill into different or dig into different parts of the mine to find where the ore is. So with imaging techniques, you can kind of in real time think that you would be able to image and understand where the ore is going, which is the equivalent in the oil and gas industry we call it well placement. And well placement is about drilling and putting the wells where the oil is. Here's about drilling and doing what you do in the mining sector, in the mining process, and really following where you have the highest grade ore and the best ore to extract most of it. I'll skip that one, and I'll finish on those thoughts, which is, we definitely see long-term demand for minerals and mining be very strong. Now the sector is sort of going through a trough, and which puts him in a mindset of a bit of a short-term mindset. But we think geoscience can address some of the challenges that we discussed earlier about that cycle time getting longer, the quality of the ore declining, the complexity of finding new ore, which is deeper and in more complex settings. Didn't elaborate too much on the data transformation, but that industry is dealing with a lot of data, the same as the oil and gas industry, and therefore having that data ready, talking to each other, de-siloed. Typically data is quite siloed, so connecting the data to each other, applying AI techniques to validate your thoughts, your geological thoughts, with different data sets is quite critical, and so data techniques and data transformation, AI can really help with that. And I think we do think, and that's why we're focusing on the minerals and mining, that definitely this is going to continue to develop over the years. And as we work with clients, that we'll be able to develop better suited solutions for the sector. But in general, I think our sort of geoscience industry has a big role to play for minerals and mining. So we look forward to it. Questions? Clear? All right, I'll just, there was one.
It was an excellent presentation.
Thank you.
Very insight about various aspects of data. My question to you is, as you have been saying that you acquire these data, you have been acquiring these data for American companies. Is there any plan to do something similar in Saudi, or is it going to be need-based, client-based data acquisition?
So it's so in general, when we do this in this model, this multi-client model, we put a project together where we feel multiple clients are interested. So you do need an environment in which multiple clients can play, can acquire land and access resources. So I'm not as familiar with the environment here, but for sure the environment in the U.S. is exactly that way. It's very easy to access the land, and there's a lot of clients, and because of the security, right, national security, there's a vibrant mining ecosystem over there. So that was a sort of a natural place to test a new business model. I have to admit and say we're looking for those clients. So right now, we're probably crossed the 50% funding for the project. So we invested X. So far, we sold to multiple clients, probably 3 or 4 clients, and we're about recovered half, which if I compare to the oil and gas industry, at the same stage, I would be probably 70 to 80% recovered. So it's the economics for us, of course, it's a much lower investment compared to the oil and gas industry. But we're testing the model, so we're pretty open to doing it in other parts of the world, provided that you have that ecosystem of clients. Or we could do it, sometimes this happens in a different way. We work with one client and they take the lead, so that client will invest. We don't invest, they invest, so they create that data set, and then they sell it to their partners. So you have different, but the idea is that because you federate a group of clients, you're able to do a lot better, right? Because instead of each investing on their postage stamps or on their little area, maybe different data sets, you have this kind of uniform view across. So it's actually should be quite cost effective. But what we find is that, our clients were not super comfortable with the model, very secretive. There's like, do you mean like my competitor can have access to the same data? They can, if they pay. But in reality, the value, I think, of a mining company is not the data itself, is what you do with the data and your knowledge, right? So the data should be okay that your competitor has access to the data, but what we're finding is many mining companies think the data is so important. It is. But you're better off having the best data set, shared across, and then that's where you add your value.
Just to add to this, since it's more local, so in the kingdom, do you gonna put a team of experts who have local knowledge of geology?
Yeah.
Or local?
Absolutely,
because reinterpreting data with respect to local knowledge is critical in this?
Absolutely. No, we do recognize the importance of local knowledge. So we have a team on the ground, and we have a partner that in the kingdom that we'll be working with. So no, we do recognize, and so this is something we're familiar with because we need to work locally, and we need to work as a team with our clients as well, because clients have been doing this forever in their country and they know it better than us. But we bring the technology, they bring the local knowledge, and you put it together, it's very powerful.
Thank you.
Okay. I'll keep in mind that I was so clear that I had no questions, or one question only. So good. Thank you very much. I appreciate it.
السلام عليكم صبحكم الله بالخير. My name is Ahmed Rida. I am an assistant professor at King Abdulaziz University. I spent the last 5 years at Adelaide University in Australia working in developing in situ rubidium strontium dating method in the triple quadruple inductively coupled plasma mass spectrometer. A lot of terms. You're probably wondering about all of them. This is what I will talk about. I will link the in situ dating with its application in mineral exploration. So let's start with the basic. What is geochronology? Geochronology is the science of measuring the age of Earth materials like minerals and rocks. In geology, understanding the mineralization periods linked to global tectonic processes is important to identify prospective mineral deposits. With the right technology, we can trace ancient tectonic events and determine when a rock or mineral deposits may have formed. We can link the rock forming process to these events using geochronology and geochemistry. And we can link this events to using the geochemistry and geochronology to understand the distribution of these events of these ore deposits around the world. So how can you use geochronology to measure the age of Earth materials? The short answer is using radioactive isotope. Now you may wonder, what are isotopes? They are atoms with the same number of neutrons, of protons, but different number of neutrons or mass number. Some of these atoms are radioactive and unstable, so they decay over time in a predictable way to reach stability. They decay alpha or beta or gamma. In alpha decay, as we see here in this slide, the radioactive atom, or what we prefer to call the parent atom, produces alpha, and this reduces the atomic number by 2 and the mass number by 4. For example, here uranium-238 decays alpha and changes to thorium-234. In beta decay, the parent atom emits a beta particle. The beta particle has a negative charge, and this increases the atomic number by 1 without changing the mass number. This type of decay results what we call isobar, where the parent and daughter atoms have the same mass but different atomic number. Rubidium strontium is a good example for this kind of decay. Cobalt-60 is an example for gamma decay. It undergoes beta decay first, converting a neutron into a proton and forming nickel-60 in excited state. This nickel-60 releases this excess energy as in a gamma form to reach its stability. Now, how can we use these isotopes for age dating? Radioactive decay happens at constant rate known as decay constant. The time it takes for half of radioactive substance to decay into its stable form is called half-life. Some isotopes like uranium-238 have long half-lives around 4.5 billion years, making them ideal to dating oldest rock in Earth. Others, like carbon-14, have much shorter half-life, just 6,000 years, and are used to date more recent materials such as bones. It's like have different tools in a toolbox. Each isotope system can be used for a specific purpose, depending on the time scale we are investigating and the closure temperature of each system. Let's have a look at some of these isotopes. With uranium isotopes with half-life of 4.5 billion years for uranium-238 and 700 million years for uranium-235, we can date ancient igneous and metamorphic rocks, and we can also date mineral deposits associated with granitoids, and we can also constrain the timing of deposition of clastic rocks. For potassium-argon and argon-argon system, they are widely used for dating volcanic rocks, and we can use them to understand the thermal history of ore deposits. Rubidium strontium system is frequently applied to date metamorphic events, hydrothermal process, and the low temperature alteration process. Samarium neodymium can be used for understanding the mantle process. Rhenium osmium system can be used to date sulfides minerals, especially those containing molybdenum, nickel, and copper. Lutetium, hafnium are suitable for dating garnet in metamorphic and hydrothermal systems. This is the complicated thing. To determine the age of the rock or mineral, we need to analyze them for their isotopic composition. And we can use this composition in these equations to calculate the ages. I will skip this complicated math. Just remember this. To get the age of the sample, we need to analyze their isotopic composition. So we need precise measurements of these isotopes, and we can do that using the mass spectrometer, or what we call mass spec. The mass spectrometer works by identifying or measuring atoms or isotopes based on their mass. On this slide, the first one here, we can see the inductively coupled plasma mass spectrometer, the triple quad one, at the University of Adelaide in Australia. The second one is the Noble Gas Mass Spectrometer in Australian National University, and the last one is the Thermal Ionization Mass Spectrometer at the King Abdulaziz University. The ICBMS shows here is the advanced version of the single quadruple inductively coupled plasma mass spectrometer, and this is cutting-edge instrument equipped with a reaction cell. We will talk about this one shortly. Probably in the industry, the most popular one is the ICBMS, the single quadruple ICBMS, because it's used commonly for geochemical analysis for major and trace elements, and also for in situ uranium lead dating. Remember this, the mass spec relies on the atomic mass number to distinguish between isotopes. So if we have two isotopes with the same number, the mass spec cannot distinguish between them. This issue is known as isobaric interference. When we are working with beta decay system like rubidium, strontium, rhenium, osmium, lutetium, hafnium, we will face this issue. For this reason, the ICBMS is not ideal choice to analyze these isotopes. And we need to separate between these isotopes in chemical lab to avoid this overlap, which is time consuming. And after that, we can load the sample or analyze them using the thermal ionization mass spectrometer or the multi-collector ICBMS. Now let's talk more about beta decay system. This system are characterized by their long half-lives, and they are useful for determining the age of ore deposits, the timing of events that form them. As I said, the challenge of these isotopes, both parent and daughter isotopes have the same mass number, and the mass spec cannot distinguish between them. Until recently, most of these systems were inaccessible for routine in situ analysis. You may ask now, why do I need in situ analysis? The advantage of the in situ analysis is that it can be performed rapidly at low cost with minimal requirements for sample preparation. Sample can be introduced to the machine in solid state rather than the liquid state, and also we can constrain the age zonation within the single grain. We can understand the textural relationship between the mineral phases, and we can also target larger grains with minimal risk from isotope disturbances, and we can avoid inclusions, and other source of contamination can exist in the sample. So considering the benefits of the beta decay system to constrain the age mineral deposits and the timing of events that shape them, it will be great if we can analyze the samples using in situ method. The answer for that, or the solution for that, is the triple quadruple inductively coupled plasma mass spectrometer. This advanced version of the single quadruple inductively coupled plasma mass spectrometer, ICBMS I would say from now, is equipped with a reaction cell placed between two quadruple. This is the first quadruple, this is the second quadruple, and the reaction gas is placed between them. What is the function of this reaction gas? We can fill this reaction gas with different kind of gas, and we can perform the chemical separation of beta systems isotopes online within the machine with no need for chemical lab. To do that, we need to link the machine into a laser ablation system, and the laser ablation system can be used to target the phase of interest with a laser beam, and the diameter of that laser beam can go down until 70 micron for rubidium strontium method and until 30 micrometer for uranium lead method. The laser beam will hit the sample surface and generate aerosol, which will be carried out into the instrument. And in the instrument, the aerosol will pass the first quadruple, and we can set the first quadruple to eliminate certain masses like 103 or 102 and allow the rest of them to go inside the instrument. When for example, here we have rubidium and strontium passing through the first quadruple. In the second phase, which is the reaction cell, strontium will react with the nitrous oxide, which we fill it in the reaction cell, while the rubidium will not react. So we can detect rubidium on mass and strontium on mass shifted as strontium oxide, and the mass of strontium oxide is 103. For this reason, we exclude 103 mass from the beginning, so it wouldn't interfere at the end of the system before the detector. We can apply the same principle to other systems, other beta systems. For example, lutetium hafnium can be separated in the machine using ammonia. Rhenium osmium can be separated using methane, and potassium calcium can be separated using SF6, and we need to mix it with helium and hydrogen to avoid the interference with argon, which is the source of the plasma in the instrument. Now let's take you to a real case study to see how we can use in situ dating, in situ rubidium strontium dating, to determine the age of the key events that shaped Jabal al-Abla. So Jabal al-Abla is a known ancient gold mine site located in the southeastern part of the Arabian Shield, and specifically in Shwas Belt. And the Shwas Belt is intruded by a diuretic unit, and the entire region has been affected by a major structure called Farwa Shear Zone. The diuretic complex showed here. It's called Abla Shwas plot, and it's intruded by several granitoids shown here in red, and Abla pegmatite is shown here in blue. Closer look at Jabal Abla. It's composed mainly of pegmatite, and this pegmatite is composed of feldspar, muscovite, and quartz. The mineralization is associated with the alteration zone within the pegmatite, and these alteration zones are closely linked to the quartz veins. In the left side in the photo, on the left side, we can see the horizon zone at the top of the pegmatite and the quartz veins. We collected samples from this exposure for rubidium strontium dating for two reasons. We wanted to constrain the timing of the crystallization of the pegmatite and the timing of the alteration event. The analysis were conducted using the Agilent 8900 ICP-MS at the University of Adelaide, linked to this laser system. Here you can see the sample holder of the sample systems. At the top is our samples prepared as thin polished section. And this is the advantage of the in situ dating. We can analyze the samples directly in solid state with no need to dissolve them as a traditional way. At the bottom here, we can see the standards or the reference materials we used for calibration and quality control. We investigated these sections under the microscope, and we noticed that there is two distinct phases of muscovite. The primary muscovite is shown here in figures A and B. The secondary muscovite is shown here in figures C and D. For the primary muscovite, it found in pegmatite and the horizon away from the alteration zone. These crystals are typically large, eohedral to subhedral, while in the secondary muscovite were found in the alteration zone appeared as the small subhedral to anhedral crystals. We also generated chemical maps for these muscovites using the scanning electron microscope equipped with the XRF to investigate the chemical differences between these phases. The elemental map showed that here at the bottom, the primary muscovite has higher iron content compared to the secondary muscovite. Here is the result of the age dating. We dated the two phases, and the primary muscovite yielded age ranged between 336 and 636 and 611 million years. The secondary muscovite yielded younger age ranged between 608 and 598. I calculated the single age for each analysis from the previous isochrons and plot them here in this box plot. As we can see at the bottom here, this group is representing the primary muscovite, and it's older than the secondary muscovite presenting in the above group. From this case study, we can see how in situ dating is powerful tool for determining the age of at the microscale. So from the slide, we saw that the primary muscovite likely preserved the crystallization time of the pegmatite. Meanwhile, the secondary muscovite preserved the timing of the alteration. So this is one of the advantages of the in situ dating. We have measured these ages at micro scale, and this allows us to determine the age of mineral deposits and the geological events that shape them using diverse set of isotopic systems. Unfortunately, despite its potential, there is currently no geochronological lab in the region can offer this advanced dating method. Here at King Abdulaziz University, we are happy to collaborate with any organization keen to establish a geochronological lab with this technology here in Saudi Arabia. I will leave my contact at the end of this slide, so just drop me a message and I will take it from that point. Regarding the limitation in situ dating beta system, for beta system is still limited to certain type of minerals because of the lack of standards or reference materials. These standards are required to calibrate the results and for quality control. Developing these standards is still an active area for research, and using this research will help us to expand the technique and to be applied to different mineral systems. It's worth to mention that the ICP missile presented here, the triple quadruple, is an old version, and now in the market there is another version equipped with multi-collector which can provide us with better precision. This brings me to the end of my presentation. Thank you very much, and I'm happy to take your questions now. Okay, no questions? Yes, go ahead.
Hello, I have one question. You said it is compulsory to make the age analysis before isotope analysis, as I understood. Is it true?
It's important to calculate the age. We need isotopic composition of the sample to get their ages.
Yeah, but I understood. Okay.
Okay.
Thank you very much.
Go ahead.
Great. I just wanted to mention at KFEPM we have a laser ablation high resolution ICP-MS where we can do
Single quadruple or triple
single
quadruple?
quad.
Yeah, this one is commonly used like for uranium lead zircon, but we cannot use it for beta decay systems.
Yeah, sure.
Yes.
That's true.
And happy to hear that you have it in KFUPM.
Yeah. Thank you.
All right, thank you very much. And feel free to contact me if you have any other questions. Thank you.
How does it start up? Yeah, let's start, yeah. Sure. Oh, that's good. Thank you. Hello. Dear Forum, I am very glad to welcome you on the next presentation. And I am very glad to introduce our ongoing activity, the Geochemical Survey of the Arabian Shield. And I'm very glad to share with you the methods, the results, and outlook to mining and mineral exploration. This is the Geochemical Survey of the Arabian Shield, GSA project. Myself, I'm Jordan, the technical partner team leader of the project. I'm a geologist and geochemist, working as a senior scientist for the Finland Geological Survey. Sure, here. Okay, so then a few words to introduce the framework of the project. The full title is High Resolution of Geochemical Survey of the Arabian Shield through stream sediment and heavy mineral concentrate samples in the Kingdom of Saudi Arabia. So the website of this forum already announces this project. Read it here. The Saudi Arabia launched one of the world's largest geochemical and geochemistry surveys. And this is what I would like to share with you on the results and the project. Indeed, this project is big. It spans 6 years from 2021, as you can see on the slide, and it finishes in 2027. The client is the Saudi Geological Survey, who contracted the China Geological Survey. The representatives are over here among the audience. You are welcome. And the technical partner, including the International Geosciences, and then the Geological Survey of Finland, which is my affiliation. So the Geochemistry Survey project is a part of the larger project. The overarching project is called the Regional Geological Survey Program, which has a couple of subcomponents, including geological mapping, the geophysical survey, which was just presented by my colleague, Dr. Fergal Murphy, an hour ago in this session. And then also we have the National Geological Database super program, and then the National Core Library, the NCL. The NCL is also presented on this forum in a special boost by my excellent colleague, Dr. Tahir Alem. So the aim of the Geochemical Survey project is to produce high-resolution geochemical maps and geochemical atlas to stimulate mineral exploration and to attract mining investment. And that's why we are here today. So let me guide you through the project, this outstanding project, from the beginning along the procedure of the project implementation. This talk will be technical in order to support and provide good science in the support of mining and mineral exploration in Saudi Arabia. So the Geochemical Survey starts with the field sampling. Sampling design and planning is the first step. So all our activities, including sampling, are guided by manuals, which are guidance documents developed by the survey, later to be published by the Saudi Geological Survey. We hope, we trust, they will become international standards later. At this stage, the sampling planning is based on the 50 quadrangles of 1 to 250,000 map sheets is the sampling design basis. And each quadrangle is subdivided eventually to the 1 to 50,000 map sheets, which cover about 25 by 25 kilometers. And then in each map sheet, 100 stream sediment samples are collected. Further on, and that's why this project is high resolution, because each 50,000 scale map are further subdivided to 10 by 10, 100 subsquares, and each cell is the basis for one stream sediment sample collection to represent a catchment for chemical composition, the eroded material from the rock in one sediment sample. And then the quality control is a very important aspect of this database. We believe that this is one of the most quality controlled geochemistry database currently internationally. So when 2 duplicates per each map sheet is allocated, 2% of duplicate samples control the quality of sampling. Oh, sorry, it's here. So here is actually what's going on. 2.5 kilometer by 2.5 kilometer cell, a low order. First or maximum third order stream is sampled for stream sediment. So this is reality, but these are still excerpts from the manual. And then once the sampling site is selected, then strips of samples are collected along a 100-meter stretch, either along the wadi, the stream, or across as it is appropriate. The project recognizes the different geochemical landscapes of Saudi Arabia, such as the flat plains, the Sabka, the Harrat, and Nafud, and the specific sample collection procedures are designed for the specific landscapes of the Arabian Shield. These pictures show the Sabka on the top and the Harrat, which is a basaltic volcanic area for sampling a unique landscape here. So this is reality. So this is a 50,000 scale map sheet supplemented with a satellite image for sample design. The black dots are the actual sampling sites, and then with a close lookup, this is how it looks like, the sampling design. This covers more than 86,000, I repeat it, 86,000 sampling locations. So once the sampling points and the sites have been identified, the next step, you have to do the job and go to the field. And that's why we geologists, geochemists, we've done, and this slide guides you through, along the arrows, the field procedure. The sample collection focuses on active stream channels, which represent the freshly eroded rock from mineralizations to the stream sediment sampling site. Then the sieving, the material collected at minimum 3 subsites is sieved to less than 2 millimeters. This is an international standard. And then homogenization is very important for representativity. I told you that quality control is an essential part of this project. And then the sample is quartered in the usual way and then split it into two boxes and then labeled properly. Then photo documentation is performed on 86,000 sites throughout the Arabian Shield. And then the CGS, the China Geological Survey Geochem Master app is used for digital field data recording. Then the samples are transported back to the base camp, and then a final field record checking is carried out, as the picture shows on the right. And the final product is shown on this picture. There are two splits of the sample. One is for archiving at SGS, the Saudi Geological Survey, and then the other goes to China, to the laboratory of the China Geological Survey. So this is how the samples are collected. This is a special picture because these photographs document the collection of the last sample, the 86,000 whatever hundred of sample collected by the SGS director, and together with CGS and TP, the technical partner. This was a ceremonial event concluding and the sampling. I'm glad to announce that all the samples have been collected. But then this is the sampling processing procedure. Remember that there are two splits. One split goes to the archive, the sample archive of the Saudi Geological Survey. However, the other is field processed to arrive to China for the laboratory analysis. And the photos on the right shows the field processing camp in Medina, established by the contractor, and there are further sieving and splitting ongoing to remove the fine alien material from the sediment. So this is on-site processing. Okay, so then the one batch of the samples, the one of the white bottles I just showed you, is archived in the excellent archiving facilities of the Saudi Geological Survey. When arrived, is fundamentally quality controlled, everything is checked, and then in the yellow crates are all coded, and the samples are double sealed, supplied with a QR code for digital reference and retrieval and for further investigation and reference. The other pass of the sample is perhaps more exciting because that enters the laboratories. This in China, at the China Geochemical Survey, we have a separate manual, a guidance document, which the project follows to carry out the laboratory analysis as well. And here it is. One unique feature of this project is that, as you can see in the periodic table, 76 chemical elements, most of the elements in the periodic table are analyzed. This is unique, has never happened before. The 77 analytes have been ever analyzed in prior geochemical surveys. So this is the laboratory. First, the samples are transported from Saudi Arabia to China, and then they arrive at the Wuhan laboratory of the China Geological Survey, and which is fully accredited according to the ISO standards, who carries out the detailed analysis, including extraction of the chemical elements from the rock, from the sediment, using ICP-MS and XRF and other suitable methods for the chemical analysis of the collected sediments. So here is a bit of insight for the laboratory analysis. So 10 different state-of-the-art laboratory methods are used and adjusted for the most suitable analysis of each chemical analysis. I call your attention to your detection limits, which are also unique in this geochemical survey. These are the lowest, or among the lowest detection limits ever produced for geochemical surveys. So, for example, note that for gold and platinum group elements, the nanogram detection limit. So, first criteria, detection limits, all detection limits are below the crustal abundance, which promotes the mineral exploration, because this is how to identify subtle geochemical anomalies in the sediment and in the rock. And then there are other mathematical or statistical criteria set for the detection limit. At least 85–95% of all the samples analyzed must be below measured concentrations below the detection limit. This is a pretty strict requirement for those who understand in the audience. Now, quality assurance and quality control makes this database very solid. For quality control, the accuracy and the precision should be analyzed and studied to make it scientifically solid and applicable for mineral exploration on a solid basis. Just to recall what is accuracy and precision. Accuracy refers to the systematic error, precision is the random error. Both are mathematically measured and tested. For the accuracy assessment, like in any laboratory, reference materials, primary reference materials, standard reference materials you can buy internationally are used, and also the project standard materials are used, which we call the secondary reference materials, representing the actual sediment in the Arabian Shield. And this is compared against the measurements in the laboratory. And then for the precision, the same thing without the details. This is the relative standard deviation. And then those who are familiar with the laboratory exercise would recognize that these are pretty strict requirements. So this is how the data looks like in reality. This is the theory, this is the reality of the data. Here you see the quality control chart for chromium for, I think, at least 2,000 samples. And these are the regular measurements of the standards with the 2 standard deviation, the 3 standard deviation error bar. You can see it's pretty persistent, the quality against both the reference material and the project material. And this slide actually shows here all the analysis for chromium, and these are the measurement, the concentration measurements for the standards. And you can see that why the measurements of the samples are fluctuating, reflecting nature, the measured concentration remains constant, which shows that the measurement is constant and of good quality. So this is the laboratory analysis. Now, for further on quality assurance and quality control, the project uses a balanced or nested design, which is the samples are split to normal and duplicate samples, and both samples are analyzed twice in the laboratory. And here's the quality control charts. So when you compare for chromium again, two duplicates, there's a very good match. And then when you compare the two laboratory analysis, then you get a very nice quality control. Note this number, the 706 repeated measurements. Myself, in my background, I've never seen so many control samples in any database in my previous career. Here we go. And then finally, an ANOVA analysis of variances is applied. This data design enables to characterize the geological uncertainty, the geological variability, the rock, and then the sampling variance, and then the analytical variance. And according to the reported and checked calculations, all the analysis has satisfied the requirements shown here with red. So this is also a quality control analysis of variance. Moreover, statistics are also calculated and presented for quality control and assurance for the data. The next step, of course, is then when all the analysis is done, the database is created, then it's a huge Excel table, so the statistics are calculated, which is useful for mineral exploration, and the maps are produced. So let's take a look. Of course, we have a manual. I guess you are already used to this. If you always have a specific manual, will be published at the end of the project. So what maps are produced, which are at the disposal of you right now here? The sample location map, the classified point maps. These are the sampling points classified for concentration for each of the selling element, and then it's a contour map with anomaly delineation. This is what we call the single element geochemical maps. This is the maps. The statistics is here for each element and for each quadrangle. This is a 250,000 scale quadrangle. In the case of chromium, as an example, the statistics are calculated and presented. Moreover, for each rock unit, the statistics are calculated, as you can see in this case for gold. And some of the rock units, such as the green one, shows that tends to have statistically higher gold concentration, promoting mineral exploration. This is how a geochemical map looks like as a close-up. This is already downloadable from the database for chromium. And this to enable to see you more, the 85% threshold of concentration is used in this project as an orientation for delineating or identifying anomalies. Anomalies are numbered, in this case for chromium, and then various statistics are calculated, including the normalized area of productivity, which is an indicator for exploration, a numeric indicator to show the potential for further investigation. And then this data is all put into the Saudi Geological Survey National Geological Database portal, and it's already downloadable. Part of it is already done at these links. So what you can download right now is the field database. It's actually an Excel table, the chemical analysis database, which I just introduced you both. And then right now, around 50,000 samples of data has been uploaded and available at your disposal. And then the same stands for the related maps, which is about exactly 1,550 geochemical maps have been uploaded both in PDF and ArcGIS digital map format. And in terms of reports, the metadata report is available for those who want to understand more how this data was generated and can be used. Capacity building is an important part of the project. It's a big project in terms of expert workshops, seminars, and joint fieldwork, which are shown in these slides, including all the three parties in the field, sample preparation, in front of the computer, and in the meeting rooms. This also shows the capacity building, the strengths of our group. The workshop, this documents the last year 3 weeks workshop shared with international presenters and lecturers from various countries. So this is where we are now. So I want to show you in the last few slides what is ongoing right now. And in our project. So on this basis, two things are now being produced to give an extra and an outlook to mining and mineral exploration. And this is one item the project is working on, the multi-element anomaly maps and reports. So this is how a multi-element map looks like. There's a predefined set of different deposit types with characteristic geochemistry or characteristic combination of elements which are searched for as a fingerprinting in these maps and databases where they fit. And when they fit, the project identifies anomalies which are also numbered and presented. For example, in this case, this is a chalcophile metals anomaly. You can read it here, metallogenic element in red, and the gold anomaly, the yellow. So the green dots show an already active mine. So it verifies that our high-resolution sediment sampling procedure identified an anomaly where a gold mine or gold deposit has been already identified with a verification. However, there are other anomalies, just right here and elsewhere in the map, which were not identified. And these are the exciting sites for further exploration and investment. The anomalies come with a lot of data. Later we can talk about the technical details, the element associations, and the ranking based on mathematics and mineral exploration considerations. So this is the multi-element map. The other major activity right now is ongoing is the heavy mineral concentrate. Not only the chemical composition, but the mineralogical composition of the eroded sediment from the rock is analyzed in this project for heavy minerals. We have, of course, a manual for this, a guidance document we follow strictly. As a follow-up on the multi-element anomaly maps. And also one piece of recent development that all the manuals, by the way, but this manual particularly, have been tested in the field in orientation surveys. So before starting the actual work, the whole group goes to the field, and then we double-check the manual, its applicability, scientific consistency against the actual field exercise, which is shown here. And the result of this orientation survey is this. So the HMC manual, the heavy mineral concentrate sampling and production is a complicated issue, but it's very important for mineral exploration. The idea is that about 10,000 sediment samples will be collected for detailed mineralogical analysis where there are multi-element anomalies identified. So this is a follow-up for the identified anomalies to derive more data in terms of information in the mineralogical composition. So against the criteria where you have high concentration in areas based on the single element maps, the large anomaly areas put together as multi-element maps, and mineralization element associations, which I just showed you. In this case, this represents 2/3 of the project. 24 target areas or target areas for HMC sampling have been identified using geology and other background information. So once these sites are identified and the sampling points are defined, this is a sedimentological issue. Those who are geologists here, that where to collect the actual sample is where the heavy mineral can settle and accumulate by nature. This is called a placer deposit in an exploration context. Is further has to be elaborated for actual field sampling, and this is what we have done. So, for example, in the field reality, when you have a number in your Excel table, so this is behind. So then, for example, small sandbars should be identified by the field crew who are trained. Training, that's why capacity building is a very important part, because 16 groups are working parallel, 16 groups, so they have to be harmonized, finding exactly the same location for all the 10,000 sites, where to collect the HMC and the wet depths, they should pick it up. And that's what we, TP, the technical partners, we are also controlling. So more than 10,000 of such mineral samples will be generated. And this is when the HFC samples are collected. The CGS, the China Geochemical Survey in Medina Base Center, established a heavy mineral concentrate processing plant, which these pictures show the spiral circuit. If you are familiar with the mineral processing technologies, but of course this is a laboratory scale setup. This is how the spiral circuit and the shaking tables are used to pre-concentrate on the site, in the field, the heavy minerals. And this picture shows our team working on this site. Sure. So this is my personal slide. Why I believe that our project is so successful is because we have a very good international cooperation hosted by the Saudi Geochemical Survey among the three parties in terms of knowledge exchange and joint interactions both in the field, in the meeting room, and in various discussions. This was recognized by the Saudi government just 2 weeks ago. The project, actually the whole project, the RGP project, received the prominent grant of an outstanding project. Congratulations. I'm very glad to share this with you. So this is a high-level confirmation that the project is proceeding well. For more information, please feel free to contact those listed here, the project management corresponding to the partners, and for more technical questions and issues, the project implementation leaders of the three parties. Thank you for your attention. Questions?
How is this different from other countries, the work that is being done in other countries, and how does it change the confidence? How is this work different from other countries in the world? Are they surveying things at the same level, and how does it change the confidence levels in the prospects of the minerals?
Thank you very much. Very, very good question. I myself, I've been working for the European Union, actually European Geochemical Atlas, the 4X Geochemical Atlas, and also the GAMAS project, including 26 and 32 European countries, which are actually the United Nations recognize these data sets as the best in the world right now. But for example, answering your question, this most ambitious European Geochemical Survey or mapping program included only 56 chemical elements. This includes 77. And also the density there was 50 kilometers. This is 2.5 kilometers. 2.5 kilometers is, I think, the length of this, the next building here. And this is for the whole Saudi Arabia. So I think this is the second one. So the third is in terms of quality. All these international surveys are quality controlled because they run under the IUGS, the International Union of Geological Union Geochemistry Global Mapping Program, which I'm also contributing myself, and also the CGS Chinese colleagues as well. So they supervise. We also use manuals, the standard procedures for all the steps. So this is, and our project is harmonized with these international standards. However, again, in terms of sampling density and in terms of chemical composition, in addition to the mineralogical composition, is also unique. Geochemical surveys don't include mineralogical analysis normally. Now we have this for 10,000 samples strong. Thank you.
Amazing presentation, amazing information. I just have 2 questions. First of all, you've taken many, as you said, more than 80,000 samples from the surface. Did you go any deep, 1 meter or 2 meters, to verify these results? This is 1. 2, when a heavy rain comes, a runoff comes as well, transporting soil from one place to another. Did you count or did you take this into account when you are verifying the results? Thank you very much.
Very good, the geochemist on board. So then thank you for your insightful question. So the sampling depth was an issue, and then was an orientation survey, quite an extensive one, before the geochemical, that was 2 years ago actually, exactly testing what is the suitable site was more or less clear. Should be a first order, first order stream, which represents the freshly eroded material in close distance, for sure. And it should be an active in sedimentology, with geologists, I guess, in this room. We understand which is active. You can see, that it's really it was impacted. Preferably the last, because we don't have streams in Saudi. That's the thing. So under this climate, these are wadis essentially, exposed to torrential heavy rain, and that's pretty heterogeneous material. So that's why for example, we collect several subsamples to be representative, because one sample couldn't represent, let's say you have a river like this. One sample that represents, thank you for the question, because very heterogeneous. So that's why we collect, actually we collect more than 3, 5, yeah, exactly. So we call 5 exactly recognizing this heterogeneity of the sediment to represent the whole sediment. Okay, so this is the location, but then the depth has been tested on the orientation surveys, and this is how we arrived at the different landscapes, such as the Sepka and the Harat and other areas require different depths, different approaches to be adjusted. There are a lot of technical details. I'm available. Also through the contacts, and then feel free to contact for technical. This is always in the manual. But then the depth is just, in principle, the only thing is the depth. We collect surface samples, essentially. It turns out it's representative. But the alien, the airborne sand, gives a lot of dilution, not to mention airborne cross-contamination. So that's the I think the main challenge in this environment, how the alien, the wind-blown sediment deposited over the stream sediment can be eliminated. In a flowing river, you don't have this problem. In Europe, for example, because the water carries out all this, and the sediment is down there. However, in this environment, so that was a big challenge, how we can, so then what we do is that when you go to the site, you remove the surface cover, because we realize that the alien cover is in active channels is thin. That's one thing, and then that's why the pre-processing in the site. There's an extra saving, indeed, to remove saving this fine alien cross-contamination. Thank you. Are there further over there? There is a question over there. The microphone, can we have, please?
Thank you. Do you have any regolith maps of the country? And I'm particularly interested in depth of cover, because geochemistry won't work in areas of deep cover, clearly.
Sure, yeah. Very good. There's no regolith map as such. These projects, remember the geological mapping is also a part of the project. We will deliver such, sort of geological information. So sure. So then in this arid climate has an advantage in terms there is no vegetation cover. So for the satellite, we took it as an advantage. Coming from Europe, everything is vegetated. Okay, that's one thing. The other thing is that so the rock is more or less bare, and then sure. Sorry, your question as I said.
Yeah, the question, I understand exactly what
there's no soil. There's no soil. Yeah.
Where there's good exposure, it's great. Geochemistry is going to work well. But when there's deep Aeolian sand, it's not going to work so well at all.
I'm sorry, yeah.
And so maybe the simple question is, do you have a map showing depth of cover?
No. Okay. But there is no soil. There's no soil cover. That's the second. No plant, no soil cover.
Yeah, but it's Aeolian sand.
But the regolith, I understand. Yeah, sure. We have the Aeolian sand, exactly. Everything has price. Thank you for your question. Okay.
Hello, amazing job done. Congratulations. My question is, how did you define the background of elements to define the anomalies in different geological suits?
Sure. Yeah, thank you very much. Yeah, this is essential. So one thing is that, so then the mineralization is represented by an anomaly, which means a positive anomaly, which means a high concentration. So this is one thing. So then, and this also areally confined. However, since this project is very high density, we have billions of samples. This gives us a very good spatial or aerial control on the anomalies. Because when you have a, let's say, a map sheet, you have a chromium, let's say a chromium, anomaly, which is just high concentration. But then we have good spatial control points all around, which has lower concentration. So that's one thing. So that's the spatial control because they have billions of samples. The other thing is the statistics. So this is operational defined 85% percentile. We were testing various percentile levels. Yeah, sure. I mean, it's up to you. So the data is there. Play your own games. So this is 85. That was because the geology and geochemistry is very heterogeneous. If you are familiar with the geology of the Saudi Arabian Shield, it's heterogeneous. So then that was one idea what you raised. And I think I showed you the statistics for the different rock types, the box plots. Remember the color block spots. So different rock types indeed have different, geochemical background and anomalies. That's a challenge. So, however, this is a regional, still it's a regional geochemical survey. So we have to keep the balance, being a survey, and of course still giving useful information for mineral exploration. But this is not a mineral exploration project, to define. That's going to be our next project, perhaps. You are welcome.
Thank you for your presentation. I have a question. What is the timeline for the release or actually fieldwork for the collection of samples in the Asir and Taflith areas?
Sorry, so the data availability for what?
Asir area terrain. So.
In the south. Yeah, actually, it's being released. So actually, right now we have. Yeah, please, Dr. Shi, can you answer this question, please?
Yes, now 60% of the chemical data released by the SGS. So the user can download from the website.
Yeah. And sorry, for the areas that haven't been covered yet in the Asir, when can we expect those? Timeline?
Okay. In half a year, something, I guess.
Maybe next year.
Okay, perfect.
Yeah. The next year, yeah. So the answer was next year, yeah, sure.
Thank you. One more question. Sure. For the areas where we do already have data, some of the elements are not available on the SGS portal, such as arsenic. Can we expect those to be released at any time?
No, that's the question, not to me. I don't know if any. Yeah, this is. Yeah, please use this context, please. Okay. Yeah, it's a very good point. I haven't mentioned out of the 77 analytes. 20 elements, which are the rarest elements, arsenic, mercury, and uranium and thorium, are confidential elements. So right now you can freely download, after registration, you can download 56 analytes, chemical elements from the website. The other 20, you have to issue a specific request using these contacts.
Perfect. Thank you very much.
Thank you. Thank you for the question, by the way. Okay. Can you see?
Yeah, just I have a question about I know you've been challenging areas, but my question: how do you collect the samples, maybe in the mountain or in Harrat area?
How they were sampled?
Yeah, how do you collect the samples in Harrat or the mountain,
Yeah, sure. These are a lot of technical questions, because we're running out of time. Please contact, but I can answer. So then the Hara, the problem is that there are no streams, no sediment actually. It is actually regolite, what the colleague already mentioned. So here we are collecting regolith sample. Okay. So there should be a certain size is defined outcrop, and then it's a clear regolith, which is actually a rock fragment. It's not sediment, it's a rock fragment. And this is how we get the Hara sample essentially. Okay.
Sure. Is it with the same distance between?
Yeah, I think so. Yeah. This was a year ago. But then, But if you're interested in these details, we are very glad to send an email, and we are very glad to share with all this video.
Thank you.
Yeah.
Thank you.
Thank you. Thank you for your interest. Okay, if there are no more questions, thank you for your attention. We are open to questions later in the coffee break.
Good afternoon, ladies and gentlemen. Please welcome to the stage Farzi Yousafali from Stratum AI. Thank you.
How about now? Nope. Yes, perfect. Hi, everybody. I'm Farzi Yousafali. I hope you've had a good start to your conference so far. This is a relatively technical talk, but I'll do my best to make it as digestible as possible. Today, especially given the audience, we'll be talking about improving the success rate of any mineral prospectivity you do, namely making your drill programs more successful using AI techniques. So, as you all know, exploration's generally a risky business. Therefore, any methods we can use today, especially those that come outside of the mining sector, should be utilized to make sure that we are able to supply our commodity needs for the next 20, 30 years as the easy to find, high-grade deposits become more and more difficult to find. So just as an overview, I won't touch on this for too long, but what Stratum does is we take whatever data a mine or a project already has, and we'll produce a better estimate of what's in the ground using non-geostatistical techniques. A little bit controversial, but hear me out. We will then use the data as is, raw data, namely collar survey assay data, to produce a prediction for a reserve estimate, increasing resources, or even going as far as improving mineral processing outcomes. The method is pretty simple. The analogy I'd like to use is like finding the snow in a mountaintop. So essentially what you have here are these features that you're trying to identify to see if you can find snow on any given picture. What you are then using is essentially a set of binoculars as you scan through the image to then pick out those features. That gives you an indication of what patterns indicate snow versus non-snow. That's a very easy way to understand the problem. Now, if we expand it to mining, you can think of it as taking a sample or a space, a land packet, and finding the attributes that would give you gold or no gold. So the way we test it is very simple. To make sure that we have a good model, we will take existing data or historical data and then predict into the future what the outcomes would look like. And we would repeat this process over and over again. You can split the data on a temporal way, so using time, meaning let's say if I start from 2020 to 2022, I would use that data to train my machine learning model and then predict blind what would happen in 2023 and 2024. In more data-sparse environments, we can replicate that technique by using drill holes and going at depth. Furthermore, we can also split up the space regionally to see how our models perform across, let's say, if you're in one western-facing region, and see how it translates towards something as you go further east. Now, rather than talking about it in abstract terms, I'm actually going to use a case study and then pull out each of the concepts as we walk through an actual project. So this is the profile. Very famous mine, especially if you're from Australia. This is Jundee Mine, an orogenic lode deposit with a very high nugget factor, meaning that 40% of the time, whatever you measure as high grade is actually high grade. Therefore, finding actual mineralization versus nuggets is quite a challenge. And you can extend this to mineral prospectivity as well in some way, shape, or form. In any case, our goal here is to use the data that is available and find new areas to then add to the mine plan. We have to consider targets that are at least 6 meters away, therefore at least 12 times further than any given block size. And we'll also have to make sure that it is greater than the economic cutoff grade, which is about 2.2 grams per ton. Now, I'm going to start with the results, and then I'm going to work how we got to that point. So the results are, given any model predicting over 5 grams per ton, so definitely considered high-grade gold in this deposit, we were 24% more efficient in finding the same number of high-grade blocks than any existing baseline drill program that had been done up to about 5 years before when we came along. The second and more important thing is that in doing these exercises, we did not sacrifice adding more drill core to find more mineralization. We actually had a higher hit rate, meaning the precision of our models was much higher than what their own models were able to produce. So let's take a step back and now think about the techniques that we can use and you can apply to each of your own projects that would help you get similar results. Not perfect, but similar. So I'll break these out into 3 categories. One is using the data fully, meaning your geochemical assays. What geochemistry would end up being good pathfinders to finding your target element, let's say gold in this case. The second is, what lithologies can we use and can be diagnosed to then map it towards our geochem assays? Because as many of you all know, lithologies are as interpretive as any geologist that produces them. Therefore, tying it to any sort of data set that is measurable is quite valuable in this case when your data environments are quite sparse. And finally, how do we measure the quality of the resource model and the confidence of any drill target? And that's quite a difficult proposition, especially when you think about how do we measure the confidence of any resource model or any prediction that you make. So we'll start with the first line, and we'll talk about a geochemical ablation study that we did at Dundee. What we did was we actually grouped the elements that were being assayed across the entire deposit into its lithological categories. Namely, group A with hafnium being the group leader, paired with zircon, and then here, specifically group E, where we have vanadium being the group leader, which is usually tied to muscovite or roscolite here. You also have some cases where you have iron and scandium and copper also tying to your mafic material, but that's pretty standard stuff. Here, what we're looking for is elements that are not gold, but will help you find the gold. That's the general idea. So, when we do an inspection, a correlation study, so to speak, we are not looking at linear correlations, because linear correlations does not add new data does not add new information to any prediction that you're making. What we're actually looking for here are nonlinear correlations. And these correlations, if I just summarize it for this particular case, we use 3 sets of correlation statistics. One is called Pearson, other one's called Spearman, and the third is called Kendall. Those 3 statistics actually allow us to create these correlation maps, which help us find zones that would be useful for predicting gold in this particular deposit. So you'll notice here, there's a nonlinear correlation of arsenic to gold, so high arsenic and high gold content. That's pretty standard, but you'll notice that what we're looking for is actually these values. If we're looking for the specific values and where that range actually lies, that is useful information as a pathfinder. In group E, specifically with vanadium, you'll notice that where there is high vanadium, gold does not occur. That is also useful information. So even though you're not necessarily finding gold, you're actually then finding the absence of gold, which will help you with your resource estimate. Same thing here in this particular scenario. Now, when we do this ablation study, we take every single element and then we match it against 2 different types of measurements. One is false positives, which can be simplified as when you predict high grade, how many instances of that is actually waste in reality? That's a false positive. So in that particular case, when we look at which elements actually help you find those instances of false positives, arsenic, scandium, beryllium, vanadium happen to be those elements. Now, in the opposite case, we're looking for mismineralization, a little bit easier to understand. In the event where you predict waste and you find high grade, is called mismineralization. We want to find those elements that would be pathfinders for those types of instances. So, as a result, we get this suite of elements. Now, mind you that these have been mapped to lithological codes that the mine has already produced. Therefore, there is some geological foundation to this type of analysis. And in reality, when we think about how we create our machine learning model, these actually become inputs, separate inputs that would then be used to predict gold itself. Now we'll talk a little bit about ensembles, which is the third line, the third topic that gets you to this increased incidence of success for your drill programs. And it's a counterintuitive idea. Usually you assume that for any given model, you will throw as much data as you can in there and then produce the best result. In reality, that might not be the best tactic because not all data is created equal, not to mention that there could be error that could be permeating through and then causing your resource estimate to skew in the negative direction. So when we think about ensembles, we think of it as different viewpoints of the same target prediction. So let's say I'm standing here at the podium and I want to predict exactly what's being said in front of me. I'm closer, but I don't have a good vantage point. In another case, if I'm standing where the cameraman is, that is a perfect vantage point for this podium here. That is a completely different input environment compared to my input environment. And we treat these models the same way. So we're not necessarily creating one perfect model. We're actually using very disparate models to see which of those predictions happen to agree on a block-by-block basis. So in practice, we use a bunch of different techniques. So we talked about ensembles, so we'll take a step back again. Now that we've talked about these different viewpoints, we can now talk about different ways of parsing your own data as inputs. In this particular scenario, you can imagine that with these high-grade nugget values, you tend to also skew your grades down when you use things like kriging and normal compositing. However, by introducing a separate channel that takes the max grade of any composite, you actually retain that information where your high-grade value happens to be measured. So in this case, they used to use 5-meter composites. If in one of those meters, especially given a block size of 0.5 meter, you'd want to retain this information. So this is an actual input we could use into the model. Finally, we'll talk about the lithology, which would then cover section 2, or topic number 2 in this particular talk. How do we take lithologies, how do we group them, and how do we test whether this lithology is actually helpful for helping you find gold, or it's more of a red herring? So in this particular case, we chose very simple groupings. One is, are we able to tell the difference between country rock and unmineralized sulfide? That tells you whether there's a potential for gold or not. That is a very simple encoding of 0, 1, and 2, where you have 0 being country rock, MZ capable, which is unmineralized sulfur, and MZ, which is actually sulfur-hosted gold. Finally, we have a separate litho channel here, which allows us to take this mafic, felsic, and sedimentary rock into account. Now, the interesting thing here to note is that this is not used for domaining. This is used for inputs, direct inputs into the model. Finally, one litho channel that is not shown here is the presence of lampopheres. The lampophere class is actually very important to find, to use as pathfinders for gold, but we'll come to that in a second. So now, coming back to topic number 3, being the ensembles, you'll notice here that even though we had lampophere information, we had the different types of compositing, we had the different types of lithos, not every single type of information is included in every single model, because each one of them contributes something a little bit different to each other as far as what type of prediction it's making. It's the different vantage points. Therefore, if, let's say, 3 of the 4 models agree on, let's say, a certain prediction in block X, that is considered a high confidence prediction and should be used for targeting. And we'll get to some examples just now in a second. So these are some reconciliation against drill holes that were done in 2023. You'll notice that we, across the board, no matter what type of model we have, we perform better than the model that they were using for their drill programs essentially. There's three different reasons for this type of improved estimate. One is machine learning over kriging, which we can talk about later. But more importantly, it's the use of these lithos and these litho groupings that are actually more valuable in finding gold. Because segmenting your lithos into its very detailed categories actually introduces more problems than it solves. So by grouping them, you just get a general idea of where the mineralization happens to be going without introducing that type of interpretation area that you tend to see with this type of estimation. And finally, most importantly, combining those models with those disparate inputs actually allows you to then produce one estimate or one prediction per block that is extremely high confidence. Therefore, when you're measuring it against the truth, let's say data that's collected in the future in 2024 or any drill program that I would execute, this would be the results I would expect. And now let's look at the converse case. The converse case is, let's say I have a great drill program and it's giving me lots of high confidence predictions. That doesn't necessarily mean that my model is precise. I could literally put a drill hole anywhere and call it high confidence. What I'm now looking for here is, can I efficiently put these holes down to ensure that I'm not wasting money every time I'm looking for high grade? So between this graph and this graph, you'll get a full picture as to how confident or how performative your models can be for drill programs specifically. So now what we get at the end is something called probability volumes. So given some number of blocks, we can actually assign a probability to them. So given a selection of ensemble models, let's say 10 to make the math really easy, if, let's say, a chunk of them tend to agree in a certain type of prediction, that is a high confidence prediction in high grade. And we can actually count the number of blocks we have that fulfill that condition. So you'll notice here that especially for such a large mine, 38% of all the drill holes that were drilled out found that the probability was above 10%, especially for this type of exploration program. That is extremely high in terms of that's an extremely high number in terms of our probability scale for what we expect to come out of the ground. This is even more true for anything above 5%. That means that these methods can be used for more risky drill programs where you're truly moving into unclassified regions or inferred regions, and you're trying to essentially create a better reserve estimate. So this is probably the best picture and gives a very good idea of what we've now built. So here you'll notice Ensemble 1 with high Lampefehr weight, meaning those pathfinders, and low Lampefehr weight. What you'll notice here is because of the ensembles that we've created, we're actually able to create a probabilistic cloud or a map of where those targets should be. So you'll notice that here and here, those targets do actually do match each other despite the lower Lampefehr weight. And then we can also compare that to what kriging produced. So you'll notice there's some differences here, where kriging does not predict those high-grade areas. So this, as a result, by using these methods and not necessarily putting all of that data together into one model, what you're able to create is this probability map, so to speak, which is directly related to how well each of the separate models agree with each other for any given prediction. So now let's actually look at some drilling that was done. You'll notice this is the before. This is an example drill target. These are some historical holes. Whoops. These were some historical holes that were put in. And here are some actual holes that were put down based on our directions. So you'll notice we actually hit this gold vein here that was missed. And what we then plotted was the lamplifiers as those pathfinders. What we then noticed was that just by using this qualitative information, that showed us that our drill programs actually work and that lamplifiers are good pathfinders, whether we conduct those drill programs or the mine does themselves. Now here's another case. This is more for resource definition, but it shows sort of how we use this type of drilling to convert very, very efficiently from anything that's indicated lower risk to higher risk, essentially adding it to your reserve estimate. So you'll notice that from before to after, we are able to move to 70% confirmed with just, I think, 1, 2, 3 holes in this case. 1, 2, and 3. Now, this is the blue sky target, which is probably more interesting. This is where this entire region is unclassified. This is infrastructure. We just put 2 holes in the ground that targeted the highest grade material we could possibly find. So here, in this purple area and this blue area would be high grade gold. Well, you'll notice that all of this material was unclassified. By using this method, we are able to project past the data boundaries and find these targets in this manner. So these are the results. We've gone over them a little bit. I won't go over them again. But what I'll note here is that by thinking about it from both a precision and a recall standpoint, namely false positive and mismineralization standpoint, you get a better idea of how well your models are performing in terms of your drill programs. Therefore, even though we found 3.2 times more material than any baseline drill programs they conducted in years past, we're still able to reduce their drilling costs by 24%. Next, I think because we have a little bit of time, I'll show you one more, which will show you some expansion type drilling, which also moves a lot of unclassified material into measured material. So this now is an IOCG copper asset in Chile. 120K geochemical samples within the asset, but then literally nothing north and south of the main manto. So we're exploring into the breccias in this case. So this is the summary. We targeted these zones here, 6, 16, and 65. Note that this land packet did not belong to them at that time. Only this did. This part of the infrastructure was theirs, and this part was also a land packet that they did not have. Using our technology, we not only noticed that there was nothing to be explored in the south region, and we ended up then directing their efforts north. Here, their belief was that there was a hard fault here that actually stopped the mineralization directly. Our analysis proved that actually what had happened was a very large shear had occurred in this zone, therefore it should be worth exploring. So not only did we find things in the infrastructure, but here I think is where it was most interesting. This was undrilled at the time. So as a result, we actually ended up with those 3 clusters alone. We found $64 million in situ value. Average grade was about 1.5% copper, which is about 3 times the cutoff grade. So I'll quickly go over those 3 concepts just so that we can have some learnings to take away from this. In this particular case, their geochemical assays had a lot to be desired. They only had copper and gold. So even though copper and gold are linearly correlated, gold did not add unique information to finding more copper or more high-grade copper. Therefore, it could not be used in this case. However, in their logging, we noticed a lot of material that was visually logged, but never assayed. And what we noticed as well was that 40% of the time, that material that was logged as country rock was actually low-grade copper. So we had to prioritize that data effectively and introduce it as a separate input, such that we still learn something, but don't introduce too much of that error that comes with that type of data. So we talked about ensembles. So here, again, we have a set of ensembles as well. So you'll notice there's some logging that we added, namely just manto, breccia, or manto plus breccia, very simple groupings. In this particular case, I'll note the ZFC, which is the visually logged material that we added as a separate input channel. And here we're combining the average composite and max composite, those concepts that we learned last time. Now here's the target, the target in the north. In this particular case, we actually found 55 meters of 0.63 copper grade. And then some outlier grades here, as you'll notice, 2.3% and so on and so forth. And then some more. So we put 5 holes in total in this particular area. The intercepts are shown here. But here's the important thing to note. Before the estimate, there was no estimate, truly. The actual percentage of high-grade volume was 36%. We found to be 36.2% of that material to be high grade. The average grade was 3 times higher than the cutoff grade, and the approximate value of just this cluster alone is about $26 million in situ. So, with that said, given the activity around mineral prospectivity and the fact that these data environments can be so sparse, it is important to be able to leverage your data appropriately so that you're not introducing some of that error that comes in when you take everything and dump it into one model. By separating that data, allocating in its proper prioritization allows you to get these types of results, because then you're only taking what's exactly useful to you and not introducing more errors as a result. Any questions? I think we have a little bit of time. There's one.
First of all, thank you for the great presentation. I just want to ask about the Ensemble machine learning. What kind of algorithm you used, and what the effect of the hyperparameter you changed to the results you have?
So the algorithms we use are deep learning algorithms, so convolutional neural networks. However, these are not like the off-the-shelf CNNs that you see today. So CNNs, convolutional neural networks, will look a lot like the LLMs, ChatGPTs that you see today. Ours do not look like that. So just take that with a grain of salt. So our convolutional neural networks are a little bit different because mining in and of itself is data. The data setting is also a little bit different. Therefore, that work is proprietary, so we'll leave that aside. The hyperparameter tuning, it has is distinctly important specifically for tuning the recall, the false positives, and the mismineralizations we talked about. Let's say, for example, I was dealing with an underground system and I wanted to think about stope optimization versus drilling. I would want a more constrained model. Therefore, I would not allow my model to have too much false positives, because then I cannot construct my stopes correctly. So those hyperparameters that you tune will tell you where you're going to, how unconstrained your model actually ends up becoming.
And the effects of that on the results, did you see any different results when you change the hyperparameter?
Yeah, so if we change the hyperparameters in this particular case to be, let's say, more precision heavy, we find that our models become more constrained. So we cannot predict, we can only really predict within inferred and indicated regions. We cannot go past the data itself, or the data frame itself. So it's just harder to extrapolate to unclassified regions because there's less confidence between, or less confluence between all of the individual models, because our threshold becomes higher. So let's say for stope optimization, here in this case we saw P greater than 10% as probability. That's okay for drilling because you're okay with missing some holes. In stope optimization, if I took that P value, it would be closer to 40-50%. That's why the differences matter.
What about other algorithms like random forest and extreme gradient boosting? Did you try this?
Yeah, we tried those algorithms. They were not able, long story short, they do not capture the complexity of any geological pattern to a level that is better than kriging. You get stuck with clustering and you get stuck with just linear types of correlations, especially when you come to random forest, because you're still stuck with linear correlations. You're not going truly nonlinear in your analyses. And there's I'll put it this way. You have a linear equation, one linear equation that dictates, let's say, some geological event, let's say a hydrothermal event. That's one linear equation. Then you have an alteration that happened on top of that. Then maybe there were some structural shears. So that's now a system of linear equations. When you look at random forest, it'll look at those linear equations separately, but they will not introduce dependencies between each other. However, with machine learning, you can introduce those dependencies. That's the easiest way I can explain it.
Okay, thank you.
Any other questions? No? Thank you so much for listening. By all means, find me, I don't know what my booth name is, but find me in the link next to the Hub of Excellence.
Good afternoon, ladies and gentlemen. We've now got Thashan Naidu from Excalibur Smart Mapping. Thank you.
Testing. Ah, great. Thank you so much. I know it's been a tiring day, but can you raise your hand if you own a mobile device? Great, because we are all part of the reason for the need for critical mineral supply. Oh, sorry, I didn't realize. Sorry. Great. Yeah. As I was saying, we are all part of the need for critical mineral supply, and part of unlocking that value lies within making use of high-resolution airborne geophysical data. So I'll touch on that briefly towards the end of this presentation, but my aim is to present a picture of where we have been with the mining evolution in Saudi to where we need to get to and how we can unlock better insights in the data that we've acquired. I know we've had a lot of talks today about the NGD access to data, but if I'm honest, I have had a lot of requests at the booth for areas of data that will be released publicly. So it's important to know that this information exists out there. So in the 1930s to the 1960s, the attention on the mining and mineral space was largely overshadowed by the oil industry, which then progressed to the establishment of Ma'aden in 1997, and that sort of put an emphasis on mining, particularly for phosphate, gold, and bauxite. And then in 2016, that was when the whole Vision 2030 came to life, and there was a large focus on trying to position Saudi as a large and competitive pillar for mining. In 2020, there was strategic discussions on mining law reforms, and I know in the last Future Minerals Forum discussion, there was some sort of high-level discussion to incentivize mining in Saudi Arabia. So with that, the objectives for Vision 2030 was trying to boost the GDP, quadrupling it. It was attention to large-scale projects, one that Excalibur is currently involved in, which is mapping the Arabian Shield. And it was creating jobs and sustainability, as well as lowering the tax rate. That has been a strategic discussion, and I cannot confirm that it has been passed, but I assume that there will be more discussions in the rest of this week to address these aspects. Okay, so the RGP project is this grand initiative that aims to map the Arabian Shield, approximately 600,000 square kilometers, of which Excalibur is flying just around 400,000 square kilometers of the Arabian Shield. And another important aspect is the geological mapping at 1:100,000 scale. The important aspect of this is the investment opportunities, and it's important to know that pre-competitive data can provide better access to exploration companies to fast-track decisions and to do more in-depth analysis. So you have more information and you can be more informed when making a decision. That's not uncommon. And this project is very globally connected in the sense that it has a lot of partners, from the technical partner moderation with IGS and GTK, and different contractors doing different aspects of the survey. Excalibur being one of them, Sanders flying another sector of the block, and the Chinese Geological Survey doing the geological mapping and geochemical analysis. An important aspect, which I think is often neglected in many projects, is the capacity building for training and development of locals in the country, particularly for young talent development. Because what has been happening in this industry is that you do have a lot of seasoned professionals, and you lack the intermediate professionals that can then transition over. You have very seasoned professionals and you have entry-level professionals. So it's quite important and remarkable that the Saudi Geological Survey is emphasizing a lot on the capacity building. All right, so this is the NGD, the National Geological Database, and we've had a lot of talks to discuss the available data on this platform. This is a very progressive attempt for Saudi Arabia because it makes available grid-based geophysical products, which you can then download. So it is a data-based geotiffs that you can then sample into a database, and you can do your own modeling. So it's quite important to know this. Making use of a platform like this could reduce data acquisition costs as a private company, as well as encouraging private sector exploration and promoting research. And it's quite important to promote various aspects of this so that you can further the knowledge of the Arabian Shield. And there has been concern on the data privacy aspect, but I would like to highlight the Australian data portal by Geoscience Australia, who encourages downloading new forms of data and integrating it into your workflow. And they have managed to find the balance between data security and furthering their knowledge. So if there's any lessons or Saudi is currently in the early phases of developing this platform. Australia has seen an abundant generation of wealth in the form of investments, in the form of development, research, by making this data publicly available. So if there's one lesson I think that we could take from the Australian portal is to encourage more accessibility to data. So that's a good step with the NGD, but I think that there will be more discussions to release other types of data. Okay, so the area that I'll be discussing or showing some of the data in is within the Asir region in block number 3. And I will show differences between the legacy data and the new high resolution data. It is quite amazing to see the resolution that we can observe, but it comes with obviously the resolution that the new data has been flown at, which is 60 meters high in reasonable terrain at 300-meter line spacing, whereas the legacy data was flown at 800-meter line spacing. So it's quite obvious that you would see a better resolution in the new data. And later on, I would show some of the preliminary interpretation approaches that we've taken to add value to this data, because having a data on the portal without extracting meaningful insights is not really useful. So in this study, I've used the legacy reduced to pole dataset, which is currently available on the NGD. I've generated a first vertical derivative from that. I've used the new high resolution data and a first vertical derivative from that. And then I will show some preliminary interpretation results. Okay, so I think it's really important to focus on the transitions here, but this is the legacy RTP. And that is the new high resolution RTP. So you can see this section here is much better defined than the previous one. The previous one, and this is the new one. And I've done the same with the first vertical derivative. So you can see that this area lacks a lot of resolution, and I think it's important to pay attention to this section here, which will be highlighted in the next transition. So you can essentially see that this structure here was not previously revealed in the legacy data. And I'll show an example later on with the geological map, which shows that this is quaternary cover. So with the new data, you're seeing some sediments structures under cover, which is incredible. And the resolution, the tightness of the edges are much better defined in the new data. Okay, so these are just some attempted structures that we were able to draw from the new first vertical derivative, right? And I wanted to overlay that on the existing geological map just to show some additional insights. This is the area that I was talking about previously, where you are seeing structures under cover. Okay, it's quite obvious that the legacy data is limited in resolution and is missing some key surface features, right? Whereas the new data is capable of detecting finer geological structures that are critical for exploration. And the effect of that is that you can obviously end up with a fewer dry holes, but we've seen from the talks today that there are many different techniques of extracting value from your data. Okay, so this shows a very nice contrast between the legacy data, which you can barely see anything here, versus the new data, where you're seeing a lot more structures. It's actually quite impressive. So yeah, this was the structures undercover that is now visible with the new data. And remember, this is available on the NGD, which we encourage many more downloads so that many more people can add their expertise and drive the geological understanding of the Arabian Shield. So this is one of the aspects that we've used to extract value from the data. And all of this is available on the NGD, starting with the mineral occurrences. So you can download that, plot it up, and create a map. What we've done is we've plot the gold occurrences and selected various areas, created a heat map from that so that we could use a technique of Fry analysis to develop or to try and understand the regional trends in this. Like all models or perspectives, it is a model. So the more data you have, the more informed your model is. And I think this is a good starting point because this is already on the portal. You have the known mineral occurrences. You have the new high-resolution data where you can develop or draw additional structures to guide a better interpretation, and then select areas that you are particularly interested in to further develop. So this was just looking at the Fry analysis of gold occurrences, and it was showing that at a local scale, you had dominant trends in north-northeast and northeasterly, whereas at a regional scale, you had orientations between north-northwest and north-south. And that was the value in using Fry analysis, was to relate directional trends at different scales. So you have your small picture, targeted, big picture, which is the element of everything in interpretation. It's important to know your scales and understand what you're looking at. The next aspect was a very unique workshop that was done by Dr. David Koza, and it was a target selection methodology that we were testing for a known location by using geophysical proxies and trying to see if we could relate that to additional areas, right? So we took an area that, and the attempt was to map alkaline rocks, right? So we took an area and we looked at the geophysical proxies, which was high radiometrics, low magnetics, and we had a look at the geochemical data. And the approach was to apply this logic to other areas, which was done successfully. But the recommendation from this is that an atlas is produced of alkaline rocks at 1:50,000 scale, which would then further inform targeted areas. So it's important to note that the locations of these alkaline rocks were associated with REEs. And that was the initial question of how many of you have a mobile device? Because as you can see, so this is the geochemical analysis. All of this data is on the NGD, so I would encourage making use of it. But yeah, this you can see that a lot of these REEs are useful in applications that we're using today. In fact, having a laser pointer probably has some REEs in this device. So, yeah. I guess concluding remarks would be, why collaborate with Saudi? Why collaborate with the Saudi Geological Survey or contractors within the space? And it's primarily because it's relatively untapped potential in the mining space. It has world-class data sets with this new release probably sometime this week, and it's in a strategic location. It's important to know that high-resolution data transforms exploration, making it faster, cheaper, and less risky. And Saudi Arabia offers great opportunities for mining and investment, and that is the purpose of this whole forum. So I think it's important that we make use of the available data sets, try to maximize value from these data sets, and not just apply the basic techniques. There's a bunch of techniques that have been discussed today, from machine learning. I know that's a buzzword, but it is a tool that can help you in identifying key areas. So there's a bunch of techniques to really extract value from your data, the currently existing data, as well as the new data that will be released sometime this week. I guess from my side, I would like to thank SGS for the constant support through this initiative, Arabian Smart Mapping for providing me the opportunity to speak here, and the Future Minerals Forum for allowing young professionals to share their opinions and have a voice at such prestigious events, because the next generation of people will need to be included in the decisions made today. From my side at Excalibur, I would like to wish everyone a prosperous and happy new year. The background video was a very nice initiative from Excalibur, which got all the employees to share their creative works. And I think creativity will take this industry forward. So thank you very much, and I hope you gained some insights.
First of all, thank you for the great presentation. I really like the difference between the legacy and the...
It's really good, eh?
It's really good. I have a question regarding the feature that you showed, which has different orientation than the other faults. Do you have any reason why it wasn't captured in the geological model, but you saw it in the...
Which...
can you go back to the geological map where you overlaid the lineaments that you interpreted? Yes, this one.
This one?
This one. So in the geological map, it doesn't see that.
Yeah, it's because of the scale of the maps that was produced.
And the quaternary cover, was it sediments?
Yeah.
There is no igneous or metamorphic in that?
No, there was nothing listed. It was produced at, I think, 250K, the map scale. This is mapping at 1:100K. So there will be differences in the detail that's there. But there will be a new map production showing additional features based on the new data that will hopefully be released in the next year.
Okay, thank you.
Okay, I guess. Oh. Yes.
Thank you. Can you tell me, will the raw data be made available to people so that we can reprocess it?
I highly doubt that the raw data will be available. I guess it would be a discussion with SGS to decide if it will be made available? No. Yeah, it's probably not going to be made available. And there are no line data available. It's just grid-based products. All right. I guess, yeah. Thank you. Thank you for listening.
Right. Good afternoon. How wonderful to be back here at the forum in Riyadh. It's a wonderful time of the year, and it certainly is a time for us all to take stock of what we intend to do over 2025. And I'm delighted that our theme, our inspiring theme for this year is impact. And today's session, we're going to be talking about what I believe is the most essential component of impact, and that is talent. Because with talent, we can achieve so much. And the initiative that we see here at Future Minerals Forum, the Centers of Excellence, the knowledge exchange, is very much about how do we bring that talent together, how do we bring that talent to work together. So thank you very much to our panelists who are joining us today at very, very senior level to give us an insight into, in particular, industry and that engagement with academia, and how we can better understand how we provide career pathways, how we inspire more of that talent into our industry. I've spent 35 years in this industry, and I can assure anyone who was considering it that it's an extremely rewarding industry, not least of all is because of the people you get to work with. So I'd like to ask our panelists each to introduce themselves very briefly, and in that introduction, give us a sense of what brings them to this topic. You know, what is important about talent? What is important about inspiring career paths into the industry? So perhaps if we start with you, Khalid.
Thank you. Yes, my name is Khalid Ahmed Al-Amoudi. I am the head of Saudi Red Brick Company. We are a brick company. In the past 70 years, we've been in this business. We developed and evaluated so long. Of course, we are in a rural area, and that's created a benefit, but also created obstacles. So one of the aim and wishes that I'd like to see further coming is to improve on the young Saudis to work in this field of heavy industries, because heavy industries mean the joints between it and the mining fields. So mining means working with earth, and earth means it's a heavy industry. So to create this marriage, if you will, between developing the Saudi young people, as we have more than close to 60% of our young Saudis that are under the age of 18. And we have roughly about 40% that graduated are going into the work field, out of which is more than 12% that are not working at all. So why not looking at other sources, instead of just going to universities and get education, go to other places where you can be educated, trained, a training center, that you can be trained to be a carpenter, to be a steel fitter, to be many sources in the engineering field, to work as a support for the top engineers and so on. And you can graduate. Don't underestimate these jobs. These jobs are the creation. Middle class and this class of people are the source and the basic of all creation of industries. Industries depend. We need a pool of source to create these sources. So I initiated in my company a center to train people, Saudis in particular, to be trained for all these sources of heavy industries, from mining all the way to production in the kilns where we have a hot environment and so on. So you can be educated that they can work with us or work in other places as the Saudis, and this is as a contribution from our company to our young Saudis, because the young population is the source. It is the bottom of the triangle, or if you will, the pyramid. And if we create this source, that means we have a continuous pool of people that are will work in the future and grow. They can grow to be any level they can be. They don't have to be all engineers. They don't have to be all doctors. This is a myth in the Arabic world. No, they can be in the field and work in the field and grow. And if you're looking in the source of money, they can make more money. But first of all, they would be educated and the right education in the field. Thank you for giving me the time.
That's incredibly valuable. So this concept of talent is much more than just getting an engineering degree.
Absolutely.
And that the minerals industry itself provides scope for a wide range of talent.
Right. Now, our government says that this is the third source of income for our country, the source of minerals. I say the fourth pillar is the young population. Without those, you cannot have a source. You cannot depend also on so many other countries to give you the source of labor. You have to create not necessarily very cheap labor, but middle class and upper class labor. Okay,
So
thank you.
Thank you so much. So John, you get to work with a lot of these people.
Yes.
From your perspective, if you could introduce.
Sure. Assalamu alaikum. Good afternoon, everybody. My name is John Humphrey. I am the chairman of the Geosciences Department at KFUPM, King Fahd University, Petroleum and Minerals. I've been in Saudi now at KFUPM for 8 years and 4 years as chairman. My focus is on, with all due respect to my colleague over here, my focus is on the scientists and the engineers who are going to take the technical roles going into the minerals industry. And I don't mean to denigrate at all the roles of the others who are not in the STEM sort of oriented areas, but our focus as a university is to develop the talent that the industry demands at the level that they demand it. Okay, and so that means not only traditional science and engineering, but also data science, artificial intelligence, machine learning, and how that can be applied towards the minerals industry, just as well as it's being applied to the petroleum industry. Now, at KFUPM, this is a relatively new area for us. We traditionally have been, when the name of the university is the King Fahd University of Petroleum and Minerals, but minerals has been sort of on the back burner for many, many years. And we've been pretty much a petroleum geoscience and petroleum engineering program. And so we're making this transition. Not only is there a transition going on between the traditional hydrocarbon side here in Saudi Arabia to carbon capture and storage and the energy transition, but also to the transition to a mineral component to the kingdom that's recognized as the third pillar of the Vision 2030 for the kingdom. So we're in that business of bringing along the talent, exposing them to the industry through the courses and field trips and interaction with the industry in order to prepare them for the next step into the job force.
Thank you, John. And I think that's a good point you make there around there is already established talent development, and Saudi leads many of these in terms of that oil and gas history, and bridging that to the minerals industry without, there's so much already there that you say exists. It's about the exposure to that.
Yes.
And part of what you mentioned is the industry. So it's a good time now to turn to Ayed and say, from your perspective, you could introduce yourself and.
Okay. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Majid al-Rifa'i. I'm the CEO of manufacturing in Ajlan Group, and I'm a chairman of Saudi Polytechnic Institution for renewable energy. Actually, the focus of Al-Ajlan Group, we are working in the upstream, midstream, and downstream for the mining sector in general, starting from the metal, from the land to the market, consisting all the process. One of the main aspects we are focusing in, it's most of the qualified technician and engineer in our sites, our target to be Saudi's citizen. There is a program, it's called Saudi Polytechnic Institution for Minerals. It's located in north of Saudi Arabia. We have signed with them more than 50 students to be educated for a qualified materials such as the drilling, chemical, safety instruction, exploration, and drilling as well. All those aspects as an investor in such new area to the market and to Saudi Arabia, it's a challenge. But with the support of Ministry of Education, Ministry of Industry, and the TVTC as well, it's a cooperation. And also the universities, they support us a lot, especially with special geophysics programs for the students. Some of the rural area in Saudi Arabia, it's very hard to find the type of mineral needed because it's either it's an old data or it's need an part of geophysics data to be investigated. So with the cooperation with all the stakeholders within the government, we are in a good position to understand where we are heading, and with the support of Saudi technicians, Saudi engineers, Saudi employees. As of today, our Saudiization is more than 50%.
Wonderful. So it's really, what I'm hearing there is it's not leaving it to randomness, but being quite deliberate in how you bring the whole value chain of education together and providing those opportunities for those being educated. Fantastic. Thank you very much. And if we, I can see you sitting there contemplating deeply. If you think about the Argas experience, if you wouldn't mind introducing yourself, and then we can, your perspective on this talent change development.
So thank you for having me here. My name is Muad Rawi. I'm the CEO of the Arabian Geophysical and Surveying Company. It's a 60 years old institute here in Saudi. So we provide wide and fully integrated geoscience services. More of, if you wish, the boots on the ground. So we perform the data acquisition to support oil and gas, energy services, geothermal, mining, geotechnical, and multiple other disciplines. Simply, if it has to do anything with Earth, we are right there. Today, Argas employ around 2,400 people, and we operate in Saudi and a few other countries around the region, including Oman, UAE, Jordan, Egypt, and Libya. So our exposure to what's so-called the super region and to our region is clear. We notice in our industry a lack of availability of people generally in the second, third lines. People today with the economic moves been moving around towards more comfortable jobs rather than field jobs. And that creates a very competitive environment. And the reason being here, and I was attracted to this panel, is the challenges that we as a service providers within this industry, whether mining or generally geoscience, is not today is alarming, but if you're gonna extrapolate towards the demand, then we are far away from where we need to be. According to different studies, we are expecting around 4 folds of manpower will be needed. And those are geoscientists, geologists, geophysicists, and as well as the people running the show, from the truck drivers all the way to labor and any kind and every kind of services. Because basically we operate a city in the middle of nowhere. You need the mechanic, you need the carpenter, you need everyone. A scientist wouldn't be able to perform the job alone. And I was honored to be part of the King Abdulaziz Earth Science Advisory Committee as well, where we address those challenges. But at the same time, we need to be realistic. We need to create jobs. There is a cyclic trend within our industry. And we need to be very careful in producing experienced people or educated people in certain fields when the market is not ready. And I keep repeating this, it takes up to 15 years to convert an area from exploration to an actual mine. So if we will get everybody on the front burner, like John is doing as an example, where we start producing so many well-educated people without finding jobs for them in the short term, then we will have that kind of challenge. We are motivated to look within the region, enhance mobility, enhance knowledge sharing, and tap into existing resources within Africa, Turkey, India, and multiple other areas to substitute that kind of demand and enhance our local economies.
That's a fascinating perspective, because it's not, you're not operating in a silo within Saudi Arabia, particularly when we talk about the minerals industry. And a statistic I can share with you is that in Australia, 50% of the engineers were not born in Australia. So the strategy of importing talent is working for Australia. In terms of developing those linkages across the super region requires negotiation and I suppose attracting the talent. What do you think enhances the attractiveness to that Saudi market for non-Saudi players?
So today the market in Saudi is the most attractive and lucrative market. I'm not saying this because I'm biased about my home country market, but in reality the availability of the job creation, the economic stability makes it a very much interesting for the most. Now, jobs availability and mobility has to do a lot with the policy making. How comfortable to create residencies, have those importation, as you have said, to accommodate a long-term investment within our community and society, something that being addressed today, I believe, as a witness of that, within the different programs of nationality and different residency programs within the kingdom. But it works both ways. Today we are sending our Saudi engineers from Saudi to Egypt. Egypt doesn't lack availability of people. We are sending Saudis to Jordan, and we are bringing Jordanians. That kind of diverse environment is critical for learning and challenging people and exposure. And that's what we are trying to build within the short term to support the long-term demand. Because it's impossible to find the four folds of people within one community. While banking is increasing, real estate is very lucrative, competitive, and you still need people on the grounds, in the field, and let's face it, it is harsh. Very harsh environment. Spend a day or two with our team in the field, and you go, I don't know how those guys, they pull it through. So what we need to do is to think about that and address that kind of harmonization, if you wish, to import it. We have signed agreement with King Fahd University, with King Abdulaziz University, with the University of South California as well, to bring in that kind of knowledge. Tomorrow we will be announcing a very important strategic alignment as well with the College of North Atlantic from Newfoundland in Canada. So we are trying to build that kind of network and training to be able to enhance the local capabilities that we have here in Saudi, import that kind of knowledge, exchange that kind of knowledge, to maximize and bring value to our communities, first of all, because business is made to serve community, and at the end of the day, serve our stakeholders.
So there's something there about building an ecosystem that's global in nature that facilitates that mobility and the access to talent. And that, I imagine, benefits Saudi, but it also benefits the other parties. So there's a mutual exchange here. Would you like to comment on that, John, in terms of the university and that engagement and what it means?
Yeah, sure. Thank you, Mark. So we're taking a several-pronged approach to talent development at the university for the minerals industry. I'm smiling because we have our female students back here who have just started in the mining engineering program that we started just 2 years ago, and we're welcoming our students into that. There's a great deal of interest in the industry right now, and a lot of that's driven by the sort of social media that's going on here in the kingdom based on the Vision 2030. Now, at the undergraduate level, so we now have a bachelor's degree program in what we're calling mining science and engineering, and again, that's only 2 years old. At the graduate level, most of our majority of our undergraduates come from Saudi Arabia. And so there's the homegrown talent that we have right there. Most of our graduate students in the geosciences come from overseas. We have a small percentage of Saudis and a much larger percentage of international students. Those international students are being exposed to, in the case of the geosciences, now they're being exposed to economic geology, coming from areas maybe they thought that they were going to work on petroleum geoscience here, geophysical exploration for hydrocarbons, but now they're seeing the opportunities here in the minerals industry. So there is cross-border fertilization that's going on there, and even while we're just getting this nascent program off the ground. There's a lot of interest in this. So my gut feeling is that this is just going to continue to grow. Now, we've seen the statistics that 250,000 new jobs are going to need to be created for this industry. And we want to be able to be technical leaders in that arena.
So it's creating the leadership opportunity, and again, attracting through one of the key things there is the responsible mining, and some of that recognizing that mining is a responsible part of being in the community at large. If I turn to you, Khaled, how do you attract talent into your programs? What are the...
What we do is we take them through a process. First, we train them. And after we train them, then we find the better quality persons. I'm not looking at the high quality training. That is for John to do. But I'm looking for the average person, the one that are not privileged for all that. They have to live and they have to work. And there is a good percentage of this that's available. And we have to look at those people as well. They don't have to be heavy talented, but they have to work and give the time and support, and by that way they are contributing to our country and to our GPD. That is how we're looking for it, because a country cannot work just on the top levels. It has to work all through, and what we have to do is to create jobs, and above all is to create the interest. What we need to do for the rural area, instead of this young kid that goes into, God forbids, into drugs or whatever, is to bring them to be educated, to learn, to love the business, to love to work with his hand, and to be creative in his job. That's what we're looking for, and that needs the support of the government to educate, whether it's through pamphlet in the high school or even in the undergraduate students, and also to educate them that yes, you can work and produce, because look, you can be any job that you have, and you can be after work in anywhere you want to, but you have to start. And working with your hand is not wrong, is perfect, is the right way to go. Look at the way other countries, Germany, Japan, or any other countries, or the United States for as well, they have to work and working and be proud. You are in England, for instance, or in Australia, to be a bricklayer is a profession that you are proud of, and it is inherited from sons to generation down the road. And this have to be created. Not only that we look out for the heavy talented, but also for the young people that needs to live, that are not really so fortunate. They have to learn, they have to live, and they have to bring money and put food on the table. And that's what we look for.
So there are many pathways to contributing.
Absolutely.
And what I'm hearing in a sense there is also parents letting go of aspirations
Yes.
that might be, there are many ways for children to grow up. And as a mother myself, my son has chosen a pathway where he's contributing, but I wanted him to do something different. And letting go of that is what I think I'm hearing you say. It's
Absolutely.
actually really important to allow the youth to pursue that contribution and providing. So Majid, how do you see that providing opportunities? Because you spoke about how the market is cyclical. There's a responsibility here as a leader to provide opportunities and inspire youth, but doing that long term as well.
Okay. The nature of business, of mining sector, it's a long-term investment and long-term a period of time. So in order to have the beauty of it, you have to classify it into different, I would say, clusters. Those clusters, each one of them, it will give you a benefit of, like as an example, let's go, we made a benchmark within our company that who's the leaders in each and every section of either in a drilling purpose or in exploration or into smelters or refinery. Then we tied up with them in different angles. One of the important angles is the educational part.
The?
Educational part.
Yep.
Okay. We have signed, as I mentioned, with one of the institutions in north of Saudi. Right now there is in process a couple of agreements with couple of universities for a certain part, especially in the geologist part or into the exploration part or into the smelter or refinery for a specified metal. Why we are targeting this approach? We are targeting this approach to assure there's a successor plan for a non-Saudi to be replaced by the Saudi for a long period of time. And then by end of the day, one of the pillars of Vision 2030 is to have an educated, qualified Saudis in different angles, either in technicians or engineer, into the different areas. And one of the important areas is the mining part.
So it really is about creating an ecosystem. And I think that is one of the greatest strengths of the Saudi approach is the Vision 2030, because there is that beacon that everyone can work towards.
And actually this is our heading target and this is our vision. Also, I can assure you that most of the companies here in Saudi Arabia, they're building their plan and strategy vision based on the Saudi Vision 2030.
So that then allows you to really invest in that ecosystem, recognizing that the other organizations are doing a similar thing. This year is, as the forum has declared, it's the year of impact. And that's clearly a stepping stone each year with these themes. If you reflect on our topic, which is the mobility, career mobility, what do you see as the greatest impact each of your organizations can make in 2025 towards this vision? What is the thing that if you could deliver that this year would be?
Okay, first of all, the mobility part, if you go to the vision of 2030, there is a part of supported programs from the government for each and every main topic. As part the mobility, they have a program, the renewable energy have a program. So each one of them, it will end up either to use the chain of the minerals. So to be a part of a supply chain of the mineral within the kingdom and assure that the educational part for each and every cluster to be localized, it's one of the targets. For sure, this target, it requires maybe 5 or 6 or 7 years. But the startup, it's from the base of it, which is within 2025.
So I'm hearing that you're feeling inspired by this.
Yes.
And inspiration generally also means there's some challenges to overcome.
See, any businesses, even in educational, there's a challenge. But you have to decide either you live with the challenge or you overcome the challenge. So once you've decided to overcome the challenge, it will be easier to you, to achieve your goals.
Thank you. And John, from your perspective?
Well, so what do I want to do in 2025? Inspiration is part of my vision here, and that inspiration is to keep the students inspired to enter this industry. There's a lot of headwinds for this industry, and it's been seen as a dirty industry. It's not maybe as environmentally sound as it should be, and there's a lot of pushback. But I think we need to develop captivating academic programs that will keep the students inspired, take them out in the field, take them to operating mines, see the industry in action. Keep that interaction between industry and academia, which I think KFUPM is really good at, and that will help keep the students engaged, and word of mouth will just get there and bring more students into it.
Fantastic. Thank you, John. And for yourself, Khalid?
Your
2025.
Okay, year 2025 is getting closer to 2030, which is actually the wish for our government and the vision. And we want to be able to contribute to this vision by helping. I wish that the percentage that we have of the Saudis that are unemployed, which is roughing between the 14 to 10%, I wish that to be zero. And to be zero, we're not just depend on the government, but we have to depend on ourselves as manufacturers, as industrialists, as businessmen, as somewhat leaders in this country, that we have to contribute to the labor force in this country to be able that everybody should able to find a work. Now, on one hand, which is I'm not against that, we have to have also foreigners work in Saudi Arabia, but a Saudi citizen cannot go back, cannot go out to its country and work. You have to work in this country, and we have to support them and to support our government to achieve that by as fast as we can to reach the 2030, where can we reach zero level of Saudi unemployed. That's my wish.
Wonderful vision for a leader to have. Thank you, Claude. Mars, from your perspective, 2025.
So at Argaz, we offer that kind of wide range of services. And think about it like a hospital. You have specialized doctors. So someone is looking after the eye, the heart, the bone, the this, the that. And it works exactly the same in geoscience. You have the geologist and the geophysicist, but due to their experience and exposure and training, you find them more in domain of the oil and gas, or at the geohazard, or underground water exploration, and so on and so forth. And what we wish or dream to achieve is to have that kind of mobility across the disciplines. You still need the deep understanding of the knowledge. Hydrologist, a geologist with understanding of geothermal or water may not be for oil and gas, or oil and gas cannot be purely for mining, and so on and so forth. But how we can bridge that gap where you will have your core team to be able to support each other, complement the gap, to overcome that cyclic, to overcome the demand, to enhance their knowledge, to enable their mobility across industries, is what we wish to achieve. And that's a critical component for our collaboration with King Fahd University, or King Abdulaziz, or South California, or College of North Atlantic. How we can achieve this with their programs, where we take an oil and gas geologist or geophysicist, and we try to groom him or her to move across industries.
So it really is that renaissance mobility across professions. which is
absolutely
within the discipline, but really being able to apply oneself to the problem rather than be a tool in the toolbox.
Absolutely, and this goes on the technical and the soft skill level as well. Today, we are running geological mapping and sampling, and the best project manager we have running that operation is actually a pure oil and gas guy. So that kind of mobility across the industries brings so much of knowledge, best practice, and I have to admit, oil and gas is miles ahead comparing to mining, with all due respect to mining, and taking the best out of each industry to build the one better operation in terms of excellence, in terms of safety awareness, in terms of environmental impact, plus the technical knowledge is what we wish to achieve.
Wonderful. I have thoroughly enjoyed, I don't know about the rest of you, but I've thoroughly enjoyed this opportunity to have such esteemed leaders on a panel. It's very rare that one has that opportunity, and here the thought leadership, the understanding of not only business, academia, but also recognizing the responsibility of a leader to the community, to the country, and to the region. And I would highlight to our industry. I am a little bit biased in the mining industry. It's been a wonderful industry to me. It's given me the opportunity to be mobile, and it's wonderful to see these leaders. If you would join me in thanking them through an applause. Thank you so much for your time, your thoughts, and your ideas. Really appreciate that. Thank you all, and I hope you find them, quiz them, and make sure they live to their 2025 visions. Thank you.
Thank you. Thank you. Thank you.
إيثار ما خلصت؟ إيثار. وجدان كم صارت الساعة؟ 10 قالوا لي 10 أبدأ إيه. ثانك يو عبد الرحمن. خلاص نبدأ. صارت 10 وجدان صارت 10. يلا نبدأ. السلام عليكم ورحمة الله وبركاته. Ladies and gentlemen, and again, ladies. Yeah. That's energy. We are delighted at FMF to see all here, all of you, in mining session. This is a networking session that our leadership was keen to create it in the 4th version at FMF. We are here to celebrate our achievements, to discuss our challenges, and to explore opportunities to be supporting to each other at the mining industry, especially that we are in the Future Mineral Forum. This session will feature an inspiring speaker from different countries. And I'm so honored to have our colleague from Women in Mining across the world here. Insightful discussion will happen here, networking opportunity to fostering the diversity and inclusion with the male colleagues and innovation in mining sector. Please allow me to start this with the nomination Saudi lady. She is working in mining and she is one of the inspirational women in mining Saudi Arabia, honored by Ma'adin Company, Mrs. Baida Al-Majid. Welcome.
Thank you. Assalamu alaikum. Good afternoon, everyone. It is truly an honor to stand here today accepting this award. Today, if I am standing on this stage, it's due to the great leadership that we having cascaded from our country, our government, to companies like Ma'adin. I'm standing on this stage and accepting this honor and saying to every woman in this industry who's striving to make difference, please allow me to say, your dreams are valid and your goals are attainable. Together, let's continue shaping a future where no industry beyond our reach. Thank you for this honor.
Thank you, Baida. Actually, when we saw Baida post every woman working on contributing in mining sector, we're proud across the, let's say, Arabian world. Then our international colleagues joined this to celebrate her. So congratulations, Baida. Congratulations to us to have you. So now we will listen to the different voices and innovation world from different countries across the world. And let's not start with the leader. Let's start with our students. So from King Abdulaziz University and Geoscience College, we have one student to tell her thoughts. Please come.
Hi, I am Lamar Sehel.
I'm a student at King Abdulaziz University, majoring in Earth Sciences. And I'm here representing my fellow students from the Faculty of Earth Sciences at King Abdulaziz. We are proud and grateful to be part of this promise field. And we look forward to contributing to the kingdom's prosperity through earth sciences and mining. We are fully aware of the pivotal role the earth sciences and mining sector plays in the kingdom's economic growth. We take great pride in being the first cohort of Saudi female students majoring in earth sciences. This milestone strengthens our ambition to become active and effective contributors to this vital sector as we move toward a future full of opportunities. Our decision to join the Faculty of Earth Sciences was a well-considered one, as we identified many opportunities this field offers to play a central role in the sustainable development of our beloved country and contribute to achieving its ambitious vision. My colleagues and I are fully committed to applying our knowledge and efforts to achieve our goals to achieve the goals we have set for ourselves in collaboration with various entities, including governmental and educational ones. Foremost, the Ministry of Industry and Mineral Resources. Finally, on behalf of the students of Earth Sciences and Mining, we thank you and appreciate your constant support and for giving us the chance to express our aspirations. This was Lamar Sahel, and thank you for your attention.
So let's go internationally. We have here Florence, my dearest friend. As the first session, I shared my thought as a woman working in geology and mining was with her. Florence from Australia, Women in Mining Australia.
Surprise! Thank you, Rana. Always beautiful to be here, and I acknowledge the incredible women who are in this room today. Global sisterhood. Thank you all so much for being here. I travelled in from Australia today. For the Australian women who are here today, nice to see you all. We have many women in mining groups in Australia, and I've been very proud to be on this journey for more than a decade. Started off as an operator and now working globally in a really great company. So really happy to be here to share every step of the journey with you all and look forward to learning more of your journeys, and thank you for your inspiration as well. Thank you.
I started my networking before anyone, so I cannot wait to the networking part of this event. Actually, the next one is a really dearest colleague from Women in Mining South Africa. Mrs. Raksha, I have with her different experience.
Thank you. Rana is surprising us all today. I have the privilege of actually sharing a beautiful story with Rana. We are characters in a wonderful adventure novel about young girls who are learning about the power of being curious and understanding and getting excited about STEM. And this is something that we all are incredibly excited about, incredibly proud of. And it's so wonderful to see so many people at this event and the wonderful work that you guys are doing here. So just continue inspiring each other and learning from one another. I think that's the greatest knowledge share that we have, are the peers that we have and the women that we engage with, and just continue to do amazing things. And soon we'll be sitting in the main auditorium having wonderful, powerful, impactful conversations, which is where we should be. So hopefully next year that's where we're going to be. So thank you and enjoy today.
Thank you, Raksha. Now I will ask if do you think we gather here only for networking? No, we are gathering here to let you know that our committee, Women in Mining KSA committee at the ministry, we are open the doors and the windows and everything to hear from you. And we will share to all the invitees who come today and attend and they register with the organizer at the door of this stage. There is a special barcode registered there. we will share the email, the official email that we will receive all the thoughts and the membership for the coming session. So maybe you see in the agenda that we will announce. Yes, we have announcement. We are working to create our Women in Mining Association. So we will be independent organization under the Ministry of Industrial and Mining Resources and the Ministry of Human Resources. We will be non-profit and officially standalone. Welcome all of you to be membership. We will launch it and publicly this in the International Day of Women this year. Thank you so much. So let's go to the group photo. Please come, ladies. If you team help me. So please come to join us in the group photo for this event. All the women's here. Please. Thank you, everyone. Now we have 15 minutes like networking, discussing, knowing each other and connecting. Enjoy.
Hello, everyone. If I can take your attention, please. Yes. Hi. Hello. We're going to start shortly. Assalamu alaikum wa rahmatullah. Hi everyone. Good afternoon and welcome to Saudi Arabia. This is Wissam Zamil, Director of Innovation at the National Industrial Development and Logistics Program, NIDLib Vision 2030 program. We are very delighted to welcome you here today. The main objective of this networking session is to give you a brief to our local and global investors on the recent partnership that NIDLib Vision is spearheading in collaboration with our partners, the Ministry of Industry, Ma'aden, ISNAD, and the Saudi Geological Survey. Today, we are participating with more than 40 global startups from all over the world to contribute to realizing Vision 2030 vision, especially in the mining sector. And this briefly, I'll give the floor to my team also to give oversight on this initiative. The main idea is that we are doing a partnership to embrace deep tech innovation and accelerate resolving of challenges, be it from exploration up to processing, as well as in waste management. And we are going to launch a very exciting announcement tomorrow and, at the 15th of January, just to promote this announcement, which is challenge-based innovation that will drive the collaboration between local ecosystem and global entrepreneurs from all over the world. I'll hand it over to Mr. Simal Mazrour, the CEO of NIDLib, to give his welcoming remarks.
Thank you, Sam. First, for the people who are coming to Riyadh for first time, welcome to Riyadh, and welcome to Saudi Arabia, and welcome to Future Mineral Forum. We're so glad and so honored to have you in Riyadh, and I hope you get time to visit the rest of Riyadh and see how beautiful this country is. For the people who are coming for a second or more times, welcome back. And we hope to have this visit more fruitful and more productive to you and to your partners. For the investors, VCs who is joining us from Saudi and from outside, this is a golden opportunity. There is a saying that the intelligent investor is realist. He sells to optimists and buy from pessimists. And I think the reality today that mining is not anymore a traditional sector. It's very, very promising. It's going through huge transformation, and time is now for you to invest and find the right partner. These 19 startups that we have today, or even more, they have been selected around the world by our partner New Lab. Thank you for New Lab, and they are one of the best around the world. So what we have today is the cream of the cream. So please capture them. They are going to do pilots with some of the largest companies in the world, and their evaluation will go high sky in a year or two. So this is the good time to catch them before it goes even higher. Considering the time, that is 5, I usually ask a question. Who believes on life-work balance? I don't, to be honest. I don't believe. I don't think life and work as opposite forces. If you don't live all your moments, whether it's you are in boardrooms, innovating, or here meeting great people, or with your loved ones, all that is actually living. And if you are not working for a purpose, you might feel that way, that you need to go out and live. Otherwise, you're enjoying being around people, working for a purpose, and enjoying life at large. So please, enjoy being with us, enjoy life while making business. Looking forward to see all the fruitful result coming from this engagement. Thank you.
Thank you so much. And we would like to also invite Mr. David Belt, the chairman of New Lab, who is sponsoring this partnership.
Thank you. Yeah, I'm David Belt, co-founder and executive chairman of New Lab. Man, it's great to be here. It's great to be here in Saudi Arabia. It's great to be here at FMF. It's amazing to be here with these incredible companies and also with this great investment community. It's funny, like this room understands what a lot of people don't, that all innovation, people think of innovation as like overnight success, right? It takes relentless incrementalism, and it takes a whole ecosystem, and it takes the ability of government and the ability of VCs and the ability of industry and the ability of startups to work together. And the suspension of disbelief necessary for a startup to succeed is so irrational and so wonderful that those are the people that I like to support and that New Lab likes to support. I want to just say one thing. I've been working now for the last year with NIDLib and in Saudi Arabia, and I've never been to a place, I've worked in many places in the world, I've never been to a place with this level of civic intent and this level of participation of really smart people trying to make their country better. And so what I said this morning to the startups, and I just want to reiterate, is we want to know what's going well, we want to know also what's difficult, and we want to try to help figure out how to bridge and bring the amazing innovation that you guys are doing to Saudi Arabia. And just as my colleague said, you know, these are great companies. These are companies, we had hundreds of companies that applied to want to be part of this. These are companies that really represent the challenge areas that we're trying to work through. Many of their technologies, though, have a lot of crossover in other aspects of hard tech. So New Lab focuses on hard tech, and it's called hard tech because it's hard. Anyway, thank you very much. I'm going to pass it over to Munif. Munif is our founding managing director here in Saudi. He's been amazing. He comes from a background at the Ministry of Energy, and we're just lucky to have him. So I just wanted him to say hello as well.
Thank you, David. It's actually difficult to follow the act of David and Mr. Suleiman as well as Wissam. There isn't much to say and add to anything they've just said, except welcome. Thank you all for being here. Some of you have flown over 16 hours to get here, so truly thank you for being here. And at the end of the day, we want this as an opportunity to help each and every one of you, the founders, get as much traction as you can and help the kingdom transform, and at the same time help the startups scale and grow. Again, enjoy the next hour or so, and thank you for being here. And it's good to be here amongst friends and colleagues. As I said, there isn't much to add, so thank you all for being here. Any questions, any problems? I would say go to someone else, but I have to be that person, so thank you.
Thank you, Munif. Hannah, we would love to use this time to also have like casual introductions between some of the VCs and the startups. So we have this floor up until 7 p.m. So please leverage it to the maximum utmost opportunity, and let us know if you have like any specific introduction you'd like to have. Like in this slide, we are featuring just only the first 19 startups. This is just a glimpse of the startups who's going to participate in the upcoming challenges, and we're going to have the announcement and open call, which will bring furthermore startups that will help us in upcoming missions and goals. Thank you so much.
you.